Right now, you are likely sitting in a room that feels solid, believing that the ground beneath your feet and the air in your lungs are permanent fixtures of reality. But theoretical physics suggests that this feeling of safety is a complete illusion, and the very fabric of our universe is balancing precariously on the edge of a bottomless abyss. There is a mathematical possibility that keeps cosmologists awake at night, a theory that implies our entire existence is a temporary accident waiting to be corrected by nature. We call this the false vacuum, and if the calculations are correct, the universe as we know it could end not in billions of years, but in the next second. Imagine that everything you see, from the atoms in your hand to the stars in the sky, is built upon a frozen lake that looks solid but is actually cracking. The standard model of particle physics tells us that the universe gets its stability from something called the Higgs field, which gives mass to every particle in existence. We have always assumed that the Higgs field is in its lowest possible energy state, like a ball that has rolled to the very bottom of a deep valley. But recent measurements of the Higgs boson suggest that we are not at the bottom of the valley, but rather stuck on a small ledge halfway down the cliff. This means our vacuum is false, a metastable state that mimics stability but is actually holding a massive amount of potential energy that is desperate to be released. All it would take is a single quantum event, a tiny fluctuation in the energy field at one specific point in space, to knock the universe off this ledge. If this happens, a bubble of true vacuum would nucleate at that spot, representing a new region of space with different laws of physics and a lower energy state. Because this lower energy state is more stable, the bubble would expand outward at the speed of light, consuming everything in its path without mercy or hesitation. The wall of this expanding bubble would be a wave of pure destruction, incinerating matter and rewriting the fundamental constants of nature as it passes through. Inside the bubble, chemistry as we know it would become impossible because the forces that hold atoms together would no longer exist in their current form. You would never see it coming because the bubble wall is traveling at the speed of light, meaning no warning signal could ever outrace the destruction. One moment you are here, reading these words, and in the very next instant, you and the Earth are simply deleted from existence. This is not science fiction. It is a prediction derived directly from the mathematics of the quantum fields that compose your body and the world around you. The terrifying part is that this bubble nucleation could have already happened a billion light years away, and the wall of death is currently racing toward us through the void. We would continue to look up at the stars, oblivious to the fact that a massive cosmic eraser is coming to wipe our history from the universe. When we look at the cosmic microwave background, we see a universe that appears stable, but this stability might be a deception caused by the limited time we have been observing. The Higgs boson discovery in 2012 at the Large Hadron Collider provided the data points that suggest we are living in this dangerous, metastable zone. If the mass of the top quark were slightly different, we would be safe. But the numbers align perfectly to place us in the zone of potential catastrophe. Some physicists argue that the universe has lasted 13.8 billion years without collapsing, so the probability of it happening today is incredibly low. However, in a universe that operates on quantum probability, low does not mean zero, and given enough time, the improbable becomes the inevitable. Consider the vastness of the cosmos and the trillions of interactions happening every second. Any one of them could theoretically trigger the phase transition. This creates a unique kind of existential horror, where the threat is not an external enemy or an asteroid, but the fundamental laws of physics themselves. We build our civilizations and dream of the future, assuming that the stage upon which we act will remain intact, but the stage itself is rotting. This theory of vacuum decay forces us to confront the fragility of existence in a way that no other scientific concept ever has. Even black holes, the most destructive objects we know, preserve information in some form, but vacuum decay offers only total, irreversible annihilation. The bubble would expand forever, converting the entire observable universe into a weird, dead geometry where life can never arise again. We are like ants building a colony on a stick of dynamite, unaware of the chemical potential waiting to be released beneath our feet. Scientists call this the great filter of physics, a hurdle so high that it might explain why we see no other intelligent life in the universe. Perhaps civilizations reach a certain level of high-energy experimentation and accidentally trigger the vacuum decay, wiping themselves out instantly. The silence of the night sky might not be because we are early, but because everyone else has already popped their bubble of existence. It forces us to ask if there are lines of scientific inquiry we should not cross, dangers lurking in the high-energy collisions of our particle accelerators. Before the first atomic bomb test, scientists feared they might ignite the atmosphere, and today we fear we might unravel space-time itself. The mathematics are indifferent to our survival. The universe seeks its lowest energy state regardless of the complex life forms that get in the way. Every second that passes without the sky tearing open is a statistical victory, a moment of grace granted by the quantum uncertainty of the cosmos. But infinity is a long time, and in an infinite universe, anything that can happen eventually will happen, somewhere and somewhen. If we are truly in a false vacuum, then the universe is not a home. It is a trap that has been set since the Big Bang. This realization transforms astronomy from a study of wonder into a study of survival and the desperate search for the true nature of reality. We look for stability in the rotation of planets and the burning of stars, but these are just surface phenomena on a deeply unstable ocean. The concept challenges our ego, reminding us that we are not the protagonists of this story, but merely transient patterns in a field of energy. There is no bunker deep enough and no shield strong enough to protect against a change in the fundamental laws of physics. This is the ultimate cosmic horror. The knowledge that the ground is not solid, the sky is not safe, and the end is instantaneous. Yet, we persist, studying the very forces that could destroy us, driven by an insatiable curiosity that outweighs our fear of the dark. Today, we will dive deep into the mechanics of this apocalypse, examining the evidence that suggests the universe is living on borrowed time. We will explore the Higgs potential, the concept of quantum tunneling, and the possible triggers that could initiate the ultimate catastrophe. Prepare to have your perception of reality shattered as we confront the possibility that everything we know is a lie waiting to collapse. The theory is sound, the math is terrifying, and the implications are absolute. Welcome to the reality of the false vacuum. To understand why the ground beneath your feet is a lie, we must first descend into the invisible ocean that fills every centimeter of the universe. We tend to think of space as empty, a vacuum where nothing exists. But modern physics has revealed that this is a comforting fiction, a simplification that hides a complex and volatile reality. In truth, there is no such thing as empty space. There are only fields, invisible grids of energy that stretch from one end of the cosmos to the other, vibrating and fluctuating in the darkness. Among these fields, there is one that is unlike any other, a field that acts as the master regulator of our reality, dictating whether atoms can form, whether stars can burn, and whether life can exist. This is the Higgs field, a ubiquitous invisible medium that we move through every second of our lives, unaware that it is the only thing anchoring us to existence. It is not a passive background. It is a dynamic, active participant in the structure of reality, and its current state is the only reason you have mass, the only reason you are solid, and the only reason you are here. But the terrifying secret of the Higgs field is that it might not be finished settling, and what we perceive as the bedrock of the universe might actually be a trapdoor waiting to open. Imagine this field as a cosmic molasses, a thick, invisible syrup that permeates the entire universe, clinging to particles as they move through it. Without the Higgs field, the fundamental particles that make up your body, the electrons orbiting your atoms and the quarks inside your protons, would zip around at the speed of light, never slowing down enough to bond, never clumping together to form matter. In that version of the universe, there are no planets, no stars, no chemistry, and certainly no biology. There is only a chaotic soup of massless radiation screaming through the void. We owe our entire existence to the fact that the Higgs field drags on these particles, slowing them down and granting them the property we call mass. This interaction is the fundamental glue of reality, the resistance that allows structure to emerge from chaos. But this mechanism comes with a hidden cost, a debt of potential energy that the universe may one day be forced to pay. By giving us mass, the Higgs field has locked the universe into a specific energy configuration, a state of being that feels permanent to us only because our lifespans are vanishingly short compared to the geological timescales of the cosmos. To visualize the danger, physicists use a graph that looks deceptively simple, often described as a Mexican hat or the bottom of a wine bottle. This graph represents the potential energy of the Higgs field, mapping out how stable the universe truly is based on the field's value. In a truly stable universe, the Higgs field would sit comfortably at the very bottom of the lowest valley on this graph, a state of minimum energy where it can rest eternally without fear of change. This is called the true vacuum, the bedrock of physical reality, where the laws of physics are set in stone and cannot be altered. For decades, scientists assumed that our universe was in this true vacuum, that the Higgs field had settled into its final, unmovable position shortly after the Big Bang. We believed we were standing on the valley floor, safe and secure in a cosmos that had finished its evolution. But the mathematics of the Standard Model, combined with the data we have recently harvested from our particle accelerators, suggests that this assumption was a fatal error in our understanding of the cosmos. We are not at the bottom of the valley, we are somewhere else entirely. The turning point in our understanding, the moment the nightmare became a scientific possibility, arrived on July 4, 2012, when researchers at the Large Hadron Collider in Switzerland announced the discovery of the Higgs boson. This wasn't just a triumph for human intellect, it was the acquisition of a specific number that would determine the fate of the universe. By smashing protons together at nearly the speed of light, scientists were able to excite the Higgs field just enough to pop a particle out of it, allowing them to measure its mass for the first time in history. The entire physics community held its breath, because the mass of the Higgs boson acts as a coordinate on the map of cosmic stability. If the mass was high enough, the universe was stable. If it was too low, the universe should have collapsed billions of years ago. But the number that flashed on the screens was 125 giga-electron-volts, GeeV, a number that sits in the most terrifying place imaginable, the metastable zone. It was not a confirmation of safety. It was a confirmation that we are living in a precarious middle ground, balancing on a knife edge between stability and total annihilation. Being in the metastable zone means that our universe is not sitting at the bottom of the valley, but is instead stuck in a small, shallow dip halfway up the cliff face. We are resting on a ledge, a local minimum of energy that mimics stability but is not the true ground state of the universe. Below us, further down the energy graph, lies the deep, true valley, the true vacuum, where the energy state is lower and the laws of physics are different. Between us and that deep valley is a barrier, a wall of energy that prevents us from sliding down immediately. This barrier is the only reason the universe didn't collapse the instant it was born. It holds us on the ledge, allowing stars to burn and civilizations to rise. But in quantum mechanics, barriers are not solid walls. They are probabilities. And given enough time, probabilities can be defied. The 125 GeV measurement tells us that the barrier is high enough to keep us safe for now, but thin enough that it is not insurmountable. We are effectively camping on a mountainside, assuming the ground is flat, while a landslide waits for a single pebble to slip. The terror of this calculation is compounded by another fundamental particle, the top quark, which plays a tug-of-war with the Higgs boson to determine the stability of the vacuum. The top quark is the heaviest known elementary particle, a subatomic monster that weighs as much as an entire atom of gold, despite being a fundamental point with no internal structure. Its immense mass pulls the energy of the vacuum in one direction, trying to destabilize it, while the Higgs boson tries to stabilize it. The fate of the universe depends entirely on the precise ratio between these two masses. When physicists plug the most accurate measurements of the top quark and the Higgs boson into the equations of the Standard Model, the result is chillingly consistent. The numbers do not place us in the safe zone. They place us squarely in the metastable region, right on the edge of the precipice. If the top quark were slightly lighter, or the Higgs slightly heavier, we could breathe easy. But nature, with a cruel sense of irony, has dialed the constants of our universe to exactly the point where existence is possible but fundamentally insecure, creating a cosmos that is perpetually living on borrowed time. This precarious state is known as a false vacuum, a term that should send shivers down the spine of anyone who understands its implications. A false vacuum is a region of space that appears stable and empty, but contains a hidden reservoir of potential energy that is itching to be released. Think of it like a lake of gasoline that has remained calm for billions of years. It looks like water, it flows like water, but it has the chemical potential to incinerate everything if a single spark is introduced. In our case, The spark isn't a flame, but a quantum fluctuation. According to quantum field theory, particles and energy are constantly popping in and out of existence, borrowing energy from the vacuum and returning it in fleeting moments. Most of these fluctuations are harmless, tiny ripples in the cosmic ocean, but there is a non-zero probability that a fluctuation could occur with just the right energy and just the right configuration to tunnel through the barrier that holds us on the ledge. This is the mechanism of our potential destruction, not a violent external attack, but a microscopic accident that unlocks the latent fury hidden within empty space itself. Quantum tunneling is the phenomenon that allows this nightmare scenario to unfold. It is the rule-breaking behavior of subatomic particles that permits them to pass through barriers they shouldn't be able to cross. In the classical world, if you roll a ball up a hill and it doesn't have enough energy to reach the top, it rolls back down. But in the quantum world, the ball can simply disappear from one side of the hill and reappear on the other, as if the hill didn't exist. This is how the sun shines. Protons tunnel through their repulsive barriers to fuse together, but applied to the vacuum of space, tunneling means that the Higgs field doesn't need to be pushed over the barrier to reach the lower energy state. It can simply tunnel through the energy wall at any random point in the universe. It doesn't require a massive input of energy or a catastrophic cosmic event to trigger it. It just requires the random roll of the quantum dice. And because the universe is vast and has existed for billions of years, the dice are being rolled quadrillions of times every second in every cubic centimeter of space. We are surviving only because the probability is incredibly low. But low is not the same as impossible. If such a tunneling event were to occur, it would begin as a microscopic phenomenon, a bubble of true vacuum, no larger than a fraction of an atom, nucleating somewhere in the vast darkness of space. Inside this tiny bubble, the Higgs field would have crashed down to the true valley floor, releasing its potential energy. This release would instantly push the walls of the bubble outward, fueled by the energy difference between the false vacuum outside and the true vacuum inside. It is a self-sustaining reaction, a cosmic combustion engine that runs on the fabric of space-time itself. Once the bubble forms, there is no stopping it. It becomes an unstoppable force of nature. The wall of the bubble, the boundary between our reality and the new physics, would accelerate instantly to the speed of light. It would expand in a perfect sphere, devouring the surrounding space, converting our false vacuum into true vacuum, and liberating more energy to drive the expansion further. It is the ultimate domino effect, where the falling dominoes are the fundamental constants of nature, and the table they stand on is the universe itself. The speed of this expansion is the key to the existential horror of the theory. Because the bubble expands at the speed of light, no information can ever travel faster than the wall of destruction. This means that if a vacuum decay bubble started in the Alpha Centauri system, 4 light-years away, we would see the light from those stars as normal right up until the moment the wall hit us. There is no warning. There is no looking up at the sky and seeing a growing black spot or a terrifying void approaching. There is no time to say goodbye, no time to realize what is happening, no time to feel pain. The optical signals carrying the image of the destruction arrive at the exact same femtosecond as the destruction itself. One moment, the world is exactly as it has always been, filled with light, gravity, and matter. And in the next Planck unit of time, it is simply gone. The nerve impulses that travel from your eyes to your brain move infinitely slower than the bubble wall. You would be dead before your brain could even register that the sky had gone dark. It is the most merciful and absolute end imaginable. But what happens inside the bubble? What is the true vacuum that replaces our reality? This is where the true strangeness of physics reveals itself. For the laws of nature are not written in stone, but are consequences of the vacuum state. Inside the bubble, the Higgs field would have a different value, likely a much higher one, or perhaps none at all. This would rewrite the masses of all fundamental particles. Electrons might become heavy as protons, or they might become massless and fly apart. The delicate balance of forces that allows atoms to exist would be shattered instantly. In our current universe, the electromagnetic force holds electrons in orbit around atomic nuclei, and the strong nuclear force binds quarks into protons and neutrons. Inside the true vacuum, these forces could have entirely different strengths, or might not exist at all. Chemistry. The bonding of atoms to form molecules, biology, water, and stars would become a physical impossibility. The complex structures of life would not burn or explode. They would simply unspool into incoherent quantum static. Matter as we understand it would cease to be matter and become something alien, disorganized, and incapable of supporting consciousness. The very geometry of space inside the bubble could change as well. Some theoretical models suggest that the true vacuum might have a negative energy density so extreme that it causes space to collapse in on itself. Instead of a new, empty universe, the interior of the bubble might instantly crunch down into a singularity, a gravitational collapse so profound that it drags the geometry of the universe into a knot. Alternatively, the bubble could be a portal to a region of space with different dimensions, where physics operates in 5, 6, or 10 dimensions, completely incompatible with the three-dimensional structures of our bodies and brains. We are creatures evolved to survive in a very specific, narrow range of physical conditions, a Goldilocks vacuum. We require stable protons, distinct forces, and a specific speed of light. The true vacuum cares for none of these things. It represents a state of nature that is more natural than our own, yet inherently hostile to everything we are. It forces us to realize that nature is not synonymous with life-sustaining. The universe's preferred state might be a cold, dead, geometric perfection where life is nothing more than a temporary anomaly. This theory fundamentally alters our perception of the Big Bang and the origin of our cosmos. It suggests that our universe might just be a bubble that formed within an even larger, older ancestral vacuum. Just as we fear a bubble forming within our space, our entire observable universe might be the interior of a bubble that nucleated in a primordial grandparent universe billions of years ago. This idea, known as eternal inflation, posits that space is constantly boiling with these phase transitions, creating a foam of universes, each with different laws of physics. In this multiverse of bubbles, most vacuums might be unstable or short-lived, collapsing instantly or tearing themselves apart. We find ourselves in this specific, metastable vacuum simply because it is one of the few that lasts long enough for stars to form and observers to evolve. This is the ultimate application of the anthropic principle. We are standing on a crumbling ledge because the ledge is the only place where we can stand. It suggests that stability is the exception, not the rule, and that the vast majority of the multiverse is a chaotic, uninhabitable wasteland of decaying vacuums. The implications for the Fermi paradox, the troubling question of why we see no signs of intelligent life in the universe, are chilling when viewed through the lens of vacuum decay. If the universe is a minefield of potential vacuum instability, it is possible that advanced civilizations inevitably trigger their own destruction. As societies advance, they build larger particle accelerators, manipulate higher energies, and probe the fundamental structure of spacetime with increasing aggression. Perhaps there is a threshold of energy, a forbidden experiment, that once conducted, locally destabilizes the Higgs field. If a civilization inadvertently creates a bubble of true vacuum in their laboratory, they don't just destroy their planet, they initiate a spherical wave of deletion that expands outward at the speed of light, silencing their entire sector of the galaxy. The reason the night sky is silent might be that anyone who gets loud enough to be heard eventually trips the wire that collapses their local reality. We might be alone simply because we are the only ones currently primitive enough to be safe from our own curiosity. But we don't need an advanced civilization to trigger the end. The universe is violent enough to do it on its own. Cosmic rays, particles accelerated by supernovas and black holes, smash into atoms with energies far higher than anything the Large Hadron Collider can produce. These natural collisions have been happening for billions of years, raining down on every planet and star in the cosmos. Proponents of safety argue that since cosmic rays haven't triggered a vacuum collapse yet, our vacuum must be more stable than the most pessimistic calculations suggest. They argue that the universe has effectively stress-tested itself for eons. However, this comfort is statistical, not absolute. Just because a coin has flipped heads a billion times doesn't mean it can't come up tails on the next throw. It is also possible that these high-energy collisions occur in regions of space we cannot see, or that the nucleation rate is just incredibly low, waiting for a rare, specific alignment of conditions that hasn't happened yet in our visible patch of the sky. The survival of the universe so far is evidence of durability, but not of immortality. There is also the disturbing possibility that the bubble has already nucleated somewhere far beyond our observable horizon. The universe is expanding, and parts of it are moving away from us faster than the speed of light, meaning they are forever causally disconnected from us. But if a vacuum decay bubble formed in a region that is currently receding but was once connected, or if the geometry of expansion changes, that wall of destruction could eventually encroach upon our domain. More terrifyingly, if the universe is infinite, then the probability of a bubble forming somewhere is 100%. In an infinite space, any non-zero probability event must happen infinite times. This means there are infinite bubbles of death expanding right now, eating away at the Swiss cheese of the multiverse. The only reason we are still here is that the distances are so vast that the bubbles haven't reached us yet. We are living in a shrinking pocket of survivability, surrounded by expanding spheres of nothingness that are continuously devouring the cosmos from the outside in. This concept strips away the human narrative of legacy and remembrance. Usually, when we think of the end of the world, we imagine ruins, fossils, or at least the atoms of our bodies remaining in the universe. We take comfort in the idea that we are star stuff, and that our matter will return to the cosmic cycle. Vacuum decay denies us even this small comfort. It is not a transformation of life into death. It is a transformation of something into nothing, or into something so alien it creates no continuity with what came before. There will be no ruins of Earth, no Voyager probes drifting in the void, no radio waves echoing our history. The bubble overwrites the hard drive of the universe. It is the ultimate data deletion. All art, all science, all love, and all memory are erased not just from the present, but effectively from the past, as the physical record of their existence is chemically unmade. It forces us to confront the idea that meaning is entirely internal, existing only while we exist, with no external validation from the universe itself. Physicists are currently racing to refine the measurements of the top quark and the Higgs boson to get a clearer picture of our fate. The current data has large error bars, margins of uncertainty that blur the line between stability and metastability. It is possible that with more precise measurements, we might find that the top quark is slightly lighter than we thought, moving us into the safe, stable zone. This would mean the vacuum is truly at the bottom of the valley, and we can sleep soundly, knowing the laws of physics are secure. Conversely, better data could push us further into the danger zone, confirming that the ledge we stand on is even more slippery than we fear. The construction of the Future Circular Collider, a proposed machine nearly 4 times larger than the LHC, is driven partly by this desperate need to know. We are building the largest machines in history to answer the simplest and most terrifying question: is the ground solid? We are poking the fabric of reality to see if it flinches, hoping that the answer is one we can live with. Some theorists have proposed exotic scenarios where a vacuum decay event doesn't just destroy the universe, but creates a new one in its wake. If the true vacuum has a lower energy state, that excess energy has to go somewhere. It gets pushed into the bubble wall, accelerating it, but it also fills the interior with a hot, dense plasma of the new physics. In a strange, twisted way, the bubble nucleation event mimics the Big Bang itself, a sudden expansion of space filled with energy. It is possible that our Big Bang was simply the result of a vacuum decay event in a previous universe, and that by dying, our universe would become the womb for a new, strange cosmos. We would be the fuel for the next generation of reality. While this offers a poetic continuity, it is of little comfort to the biology that must be incinerated to make way for the new tenets. It suggests a cyclical cosmology of bubbles popping within bubbles, an eternal chain of destruction and creation where stability is just a temporary pause in a cascading waterfall of energy. The psychological weight of this theory is heavy because it removes the concept of a future as a guarantee. We evolved on a planet where seasons cycle, tides return, and the sun rises every day, conditioning our brains to expect continuity. Vacuum decay introduces a variable that breaks this conditioning, a termination event that has no cause and effect precursor we can observe. It is the sword of Damocles hanging over the collective head of the species by a thread of quantum probability. It makes every moment of existence technically a miracle, a statistical anomaly that persists against the odds. Yet, paradoxically, this knowledge can be liberating. If the universe can end at any second without warning, then the only moment that truly possesses value is the present one. It strips away the anxiety of the distant future because the distant future is not promised to the stars, let alone to us. It forces a radical acceptance of the now, framing our existence not as a permanent right, but as a fleeting, precious accident of high-energy physics. While the Higgs field is the primary suspect in this cosmic crime thriller, it is not the only potential agent of vacuum instability. There are theories involving dark energy itself, the mysterious force accelerating the expansion of the universe, that propose it too could be metastable. If dark energy is not a constant but a field that can decay, we could face a big rip or a big crunch triggered by a phase transition in the vacuum energy. This is known as the phantom divide, a boundary in the equations of state for dark energy. If the universe crosses this line, the vacuum itself could tear apart, not just rewriting the laws of physics, but shredding the fabric of space-time until the distance between every atom becomes infinite. This scenario differs from Higgs decay, but ends in the same silence. It highlights that our ignorance of the dark sector, which makes up 95% of the universe, is a massive blind spot in our safety assessment. We are confident in our understanding of the 5% of normal matter, while drifting in a sea of dark forces we can barely name, let alone predict. But let us return to the bubble, specifically the thin wall approximation that physicists use to model its growth. The wall of the bubble is a soliton, a self-reinforcing wave packet that maintains its shape as it travels. As it sweeps through space, it converts the potential energy of the false vacuum into kinetic energy of the wall. This means the wall gets thinner and more energetic the further it expands. When it hits a star, the star doesn't just explode, it is fundamentally processed. The protons and neutrons in the star's core interact with the bubble wall, dissociating into their constituent quarks and gluons, which then reorganize according to the new physics of the interior. The star is not blown apart in a conventional sense. It is transmuted. It disappears from our universe, and its mass energy is added to the budget of the growing bubble. A civilization orbiting that star would see their sun vanish an instant before they themselves were processed. There is no explosion to watch, only a sudden, silent subtraction of reality. Is there any way to stabilize the vacuum? To shore up the cliff and prevent the landslide? Some speculative physics suggests that high-energy processes or the presence of intense gravitational fields might locally stabilize the Higgs field. For example, the environment near a black hole event horizon is so extreme that it might modify the local vacuum state. However, this offers no protection for the rest of open space. We cannot engineer the vacuum on a cosmic scale. We are barely capable of engineering the climate of a single planet. We are passengers on a ship we did not build and cannot steer, sailing through waters we do not understand. The hubris of humanity is to believe we can control our environment, but vacuum decay reminds us that the environment creates us, sustains us, and can discard us with a shrug of its quantum shoulders. The universe is under no obligation to be habitable, and the fact that it is habitable right now is a happy accident of the current energy levels, an accident that can be corrected at any moment. Consider the concept of Boltzmann brains in relation to vacuum stability. In an infinite fluctuating vacuum, it is statistically more likely for a single conscious brain to spontaneously fluctuate into existence with false memories of a past than for an entire orderly universe to evolve. If the vacuum is truly unstable and fluctuating, then our perception of a long, consistent history might be an illusion generated by a momentary dip in entropy. While vacuum decay is a physical threat, this is an epistemological threat. The idea that our past is fake and our future is non-existent. Vacuum decay is the physical manifestation of this chaos. It is the universe reverting to the mean, erasing the complex, low-entropy structures like galaxies and brains, and returning to a high-entropy equilibrium. We are fighting a losing battle against the second law of thermodynamics, and vacuum decay is simply the universe's most efficient way of balancing the books. It is the ultimate heat death, accelerated to the speed of light. There are also models that suggest the universe is cyclic, and that vacuum decay is the mechanism of the cycle. In the Steinhardt-Turok model, or conformal cyclic cosmology, the end of one eon is the beginning of the next. The decay of the vacuum cleans the slate, smoothing out the universe and preparing it for a new Big Bang. In this view, Vacuum decay is not a tragedy, but a necessity. It is the forest fire that clears the dead wood to allow new growth. Without the instability of the vacuum, the universe might become stagnant, filled with dead stars and black holes, frozen in eternal boredom. The decay resets the clock. It re-energizes the cosmos. But for the trees that are burning, for us, for our history, for our struggles, this cosmic perspective offers no solace. We do not want to be the fertilizer for the next universe. We want to exist in this one. This conflict between the cosmic need for renewal and the biological imperative for survival is the core of the existential dread vacuum decay evokes. Even if we accept the risk, the question remains, why is the mass of the Higgs boson 125 GeV? Why that specific number? This brings us to the hierarchy problem in physics, the mystery of why gravity is so much weaker than the other forces, and why the Higgs mass is so light compared to the Planck mass. Some physicists believe this fine-tuning implies supersymmetry, a theory that predicts every particle has a heavier partner particle. If supersymmetry is true, these partner particles would stabilize the vacuum, canceling out the destabilizing effects of the top quark. We would be safe. But the Large Hadron Collider has failed to find any evidence of supersymmetric particles. The more we look, the more it seems that supersymmetry might not exist, or if it does, it is broken in a way that doesn't help us. The absence of these savior particles leaves us back on the ledge, unprotected. It seems the universe is not designed with the elegant symmetry we hoped for, but is instead a messy, dangerous place built on arbitrary numbers that just happen to allow us to exist for a brief moment. The precision of our measurement of the top quark mass is currently the biggest source of uncertainty. We know it is around 173 GeV, but the error bars are just wide enough to give us hope, or seal our doom. A change of just 1 or 2 GeV in our measurement would shift us from the metastable zone to the stable zone, or deeper into the instability. This means the difference between eternal life for the universe and sudden death lies in the third decimal place of a subatomic measurement. It is a stark reminder that the devil is in the details. We are building massive detectors to chase down these decimal places, treating them like the coordinates of a ticking time bomb. Until we pin down that number with absolute certainty, we are living in Schrödinger's universe, both dead and alive, stable and collapsing, waiting for the measurement that collapses the wave function of our collective anxiety. Let's reconsider the speed of the collapse. While special relativity dictates that nothing can travel faster than light through space, the expansion of space itself can exceed this limit. However, the bubble wall moves through space, so it is bound by the speed of light. But because the universe is expanding, there are regions of space receding from us faster than light. If a bubble nucleates in one of those regions, the expansion of the universe might carry it away from us faster than the bubble can grow toward us. In this scenario, we are in a cosmic race, the expansion of space trying to push the danger away versus the expansion of the bubble trying to catch us. It is possible that we are surrounded by bubbles that will never reach us, because the dark energy driving the universe apart is saving us from the vacuum decay. We would be isolated in a safe island universe, protected by the very expansion that is isolating us from the rest of the cosmos. Safety, in this case, comes at the cost of eternal loneliness. But this protection is only temporary if the expansion of the universe slows down or reverses. If the universe eventually recollapses in a big crunch, all those distant bubbles will come rushing back toward us. Or, if dark energy is constant, we remain safe from distant bubbles but still vulnerable to one nucleating right here in our own backyard. The local nucleation rate is what truly matters, and that rate depends on the temperature of the universe. In the early universe, just after the Big Bang, the temperature was incredibly high, which should have triggered thermal fluctuations capable of hopping over the barrier. The fact that the universe survived its fiery youth is the strongest evidence we have that the barrier is reasonably high. We survived the hottest fires of the Big Bang without falling off the ledge, so the lukewarm cold of the current cosmos should be relatively safe. Unless, of course, the barrier itself is changing over time. If the parameters of the Higgs field evolve as the universe ages, the wall protecting us could be slowly lowering, preparing to drop us into the abyss in the deep future. The idea of the doomsday argument applies here. a probabilistic argument that suggests we are likely living in the middle of humanity's timeline, not the beginning. If vacuum decay is the inevitable end of all civilizations, it acts as a probabilistic upper bound on how long any observer can exist. If the average lifespan of a universe before decays is, say, 20 billion years, it would be incredibly unlikely for us to find ourselves at the 100 billion year mark. The fact that we are observing the universe at 13.8 billion years, a relatively young age compared to the potential lifespan of stars, might be a hint. It might suggest that universes don't usually last much longer than this. We might be nearing the typical expiration date of a metastable vacuum. We look at the red dwarf stars that can burn for trillions of years and assume the universe will last that long. But maybe those stars are just optimistic fuel tanks for a vehicle that is destined to crash long before they run dry. There is also a connection to the concept of brains in string theory. If our universe is a three-dimensional membrane floating in a higher dimensional bulk, vacuum decay could be the result of our brain colliding with another brain. This collision, known as the ekpyrotic universe theory, would look like a sudden, fiery reset of the laws of physics, indistinguishable from vacuum decay to the internal observer. In this view, our stability is threatened not just by internal quantum fluctuations, but by the movement of massive higher-dimensional objects we cannot see. We are like bacteria living on a sheet of paper blowing in the wind, unaware that another sheet of paper is about to slap into us. The sudden release of energy would revitalize the cosmos, but sterilize our current reality. It reinforces the idea that we are small, blind, and vulnerable to forces that operate on a scale of reality completely orthogonal to our perception. Scientific paradoxes often resolve themselves in unexpected ways, and the stability of the vacuum is one of the greatest paradoxes of our time. We have a theory, standard model, that is the most successful in human history, predicting experimental results to 12 decimal places, yet it predicts that we shouldn't be here. This screams that there is new physics waiting to be discovered. Something is missing from our picture, some stabilizing mechanism or particle that we haven't found yet. Dark matter is the most obvious candidate. It constitutes 27% of the universe, yet we don't know what it is. If dark matter interacts with the Higgs field, even weakly, it could fundamentally alter the stability landscape. It could be that dark matter is the ballast in the ship of the universe, the invisible weight that keeps us upright. Until we identify the nature of dark matter, our calculations of vacuum stability are based on incomplete data. We are calculating the structural integrity of a building while ignoring 85% of its materials. Another possibility is that gravity itself stabilizes the vacuum. The calculations that predict instability usually ignore gravity because it is so weak at the particle scale. But in the context of vacuum energy, gravity might play a crucial role. This leads us to the holy grail of physics, quantum gravity. We do not yet have a working theory that combines quantum mechanics and general relativity. Vacuum decay sits exactly at the intersection of these two theories. It is a quantum event that reshapes space-time geometry. Without a theory of quantum gravity, our predictions about vacuum decay are approximations. It is possible that when we finally understand how gravity works at the quantum level, the instability will vanish from the equations, revealed as a mathematical artifact of our ignorance. Or, conversely, quantum gravity might reveal new and even faster ways for the universe to decay. Ignorance is not safety, it is just a lack of foresight. The visual of the vacuum decay is hauntingly beautiful in simulations. It begins as a single point of light, a nucleation seed, which then expands into a sphere. The surface of the sphere is a mirror-like boundary, reflecting the twisted light of the dying universe around it. Because the interior has negative geometry or different optical properties, looking at the bubble might be like looking into a perfect, distortion-free mirror or a black hole that glows. As it eats stars and galaxies, it leaves no debris, just a growing volume of otherness. To an observer far enough away to see it, if light speed allowed, it would look like a hole being burned in a film reel, a growing white or black spot where the movie of reality simply stops playing. It is the ultimate censorship of the cosmos, erasing the messy, complex story of the universe and replacing it with a blank page. We must also consider the philosophical resilience required to study this. The physicists who calculate these probabilities go home to their families, pay their mortgages, and plan for retirement, all while holding the knowledge that it could all end in a femtosecond. This cognitive dissonance is necessary for sanity. We cannot live as if the vacuum is about to decay, just as we cannot live thinking about our own biological mortality every second. We compartmentalize the horror, treating it as an abstract mathematical curiosity rather than a physical threat. But the numbers on the page don't care about our psychological defenses. They stare back, unblinking, indicating that the universe is under no obligation to respect our plans. This theory is the ultimate memento mori, a reminder of death written not on a tombstone but in the fundamental constants of nature itself. It teaches us that existence is a privilege, not a right, and that durability is an illusion. Let us zoom in on the specific mechanism of the Higgs field again. The field has a value everywhere, even in empty space. This value is non-zero, which is weird in itself. Usually, fields want to be zero. The Higgs field, hanging out at a non-zero value, is what breaks the electroweak symmetry, separating the electromagnetic force from the weak nuclear force. Inside the true vacuum, this symmetry might be restored. The forces would merge back together. Light, photons, and radiation, W and Z bosons, might become indistinguishable. In such a universe, light as we know it wouldn't exist. It would be replaced by a unified electroweak radiation that behaves completely differently. Imagine a universe where you cannot see, because the very concept of seeing relies on electromagnetism being a distinct force. It would be a blind, hot, symmetric hellscape where structure is forbidden by the laws of physics. It is a return to the conditions of the Big Bang, a rewinding of the cosmic clock to a time before complexity was possible. Is there any way to detect a bubble before it hits? Technically, no, because it moves at light speed. However, some theories involving gravitational waves offer a glimmer of a warning. If the bubble wall accelerates to ultra-relativistic speeds, it might push a wave of gravitational distortion just ahead of it. Or the nucleation event itself might send out ripples in spacetime. But since gravitational waves also travel at the speed of light, they would arrive at the same time as the death wall. There is no outrunning it. We are trapped in the causal structure of the universe. The only hope would be if the bubble wall moves slightly slower than light due to friction with the plasma of the universe. If it moves at 99.9% light speed, we might get a few seconds of warning. A sudden, unexplained distortion of the stars, a gravitational shear that rips the Earth apart moments before the vacuum wave arrives to finish the job. A few seconds to realize the sky is falling. The many-worlds interpretation of quantum mechanics adds another layer to this nightmare. If every quantum probability happens in some branch of the wave function, then there are branches of reality where the vacuum has already decayed. In fact, there are infinite branches where we have already been wiped out. We only experience this branch because it is one of the surviving ones. This creates a survivor bias called quantum immortality. We might see the universe as stable simply because we can't observe the timelines where it collapsed. We are surfing on the crest of a breaking wave, constantly surviving only because the versions of us that died can't complain. This implies that as time goes on, the fraction of surviving branches gets smaller and smaller. We are becoming increasingly rare, essentially lucky ghosts haunting a universe that is mostly dead in the multiverse probability space. What if we are the trigger? This is a staple of science fiction, but it has roots in genuine concern. In 2008, before the LHC was switched on, lawsuits were filed fearing it would create a black hole or a vacuum bubble. Physicists dismissed this, correctly pointing out that cosmic rays hit Earth with far more energy than the LHC. But what if we build a collider the size of the galaxy? A Planck energy accelerator? At some point, an advanced civilization might reach energies that do exceed natural background events. If we concentrate enough energy in a small enough volume, we could locally heat the vacuum enough to hop over the barrier. This leads to the zoo hypothesis variant. Maybe the aliens are silent because they know that high-energy physics is a suicide pact. They stay quiet, keep their energy consumption low, and hide, fearful of waking the sleeping dragon of the vacuum. But we must also consider the island of stability concept. In nuclear physics, there are predicted heavy elements that are stable. Perhaps the vacuum landscape has other stable valleys further down. Maybe the transition to the true vacuum isn't a drop into chaos, but a drop into a better universe. A universe with 4 spatial dimensions, or a universe where faster-than-light travel is possible. Maybe life in the true vacuum is superior, forms of pure energy, or complex hyperdimensional structures that look at our biological squalor with pity. We fear the change because we are adapted to this vacuum, just as a fish fears the air. But objectively, the true vacuum might be a richer, more complex realm. We are fighting to preserve our puddle, unaware that it is evaporating into an ocean. Of course, this is pure speculation. The math suggests destruction, but the heart hopes for transformation. Let's step back and look at the cosmos today. It looks peaceful. The stars drift, the planets spin. It is hard to reconcile this visual tranquility with the violence of the theory. This disconnect is the core of the cosmic horror genre, the juxtaposition of the mundane and the catastrophic. The universe hides its teeth well. We live in a calm period between storms, a false peace maintained by the metastable plateau. This deceptive calmness is why the discovery of the Higgs mass was so shocking. We expected the universe to confirm our feeling of safety. Instead, it handed us a diagnosis of terminal instability. We are like a patient who feels perfectly healthy but has just been told they have a ticking time bomb in their chest. The sky hasn't changed, the stars haven't dimmed, but our understanding of them has darkened irrevocably. The vacuum decay theory also interacts with the ultimate fate of the universe in the heat-death scenario. If the vacuum doesn't decay, the universe will continue to expand and cool until all stars burn out and entropy hits its maximum. This is a slow, agonizing death by freezing. Vacuum decay offers a fast exit. In a way, it is a mercy. Rather than trillions of years of cold, dark solitude, where civilizations slowly starve for energy, vacuum decay ends the story while the party is still going. It is the difference between a long, lingering illness and a sudden heart attack. Philosophically, one might argue which is worse. The slow fade allows for legacy, for memory, for a long twilight. The sudden snap erases potential. But from the universe's perspective, both are just pathways to equilibrium. The universe inevitably seeks rest, whether by slowly cooling down or by rapidly falling to a lower energy state. We are currently mapping the stability wedge of the universe with greater precision. This is a graph plotting the Higgs mass against the top quark mass. The regions are labeled, quote, stable, unstable, and metastable. We are in the narrow sliver of metastability. If future measurements shift the dot into the unstable region, it implies the universe shouldn't exist at all, which would mean our understanding of early cosmology is fundamentally broken. If it shifts to stable, we celebrate. But the fact that it sits right on the line is suspicious. Some physicists call this criticality. It suggests that the universe organizes itself to be on the edge of phase transitions. Systems at the critical point are often the most complex and interesting, like the boundary between liquid and gas. Maybe life can only exist in a metastable universe. Maybe stability is too rigid for complexity, and instability is too chaotic. We exist on the edge of the knife because the edge is the only place where anything interesting happens. This brings us back to the anthropic principle, but with a twist. Usually we say the universe is fine-tuned for life. But here, it seems fine-tuned for danger. It is fine-tuned to allow life, but also to threaten it constantly. It is like building a house on a cliff edge to get the best view, accepting the risk of the fall. The fine-tuning of the Higgs mass is one of the deepest mysteries in science. Why 125 GeV? Why not 120, unstable, or 130, stable? The number feels deliberately chosen to maximize tension. It implies that the mechanism generating these masses, whether it's string theory, the multiverse, or something else, has a preference for criticality. We are the children of the precipice, evolved to survive in a universe that is fundamentally unsafe. There is a theory called vacuum engineering that suggests a sufficiently advanced Type 3 civilization could artificially stabilize the vacuum in their local region. By manipulating the fields on a galactic scale, they could build a great wall of energy that raises the barrier locally, creating a safe harbor in the metastable ocean. If such civilizations exist, they would be the masters of physics, effectively legislating the laws of nature within their domain. They would look at us, in our natural, unprotected vacuum, as primitives living in a flood zone without levees. Perhaps the dark matter we see is actually the signature of their engineering. the gravitational shadow of their stabilization structures. We might be seeing the evidence of their safety measures without recognizing it, mistaking their dikes and dams for invisible particles. But for us, with our current technology, we are helpless observers. We can calculate the probabilities, we can stare at the equations, but we cannot change the constants. The top quark is as heavy as it is. The Higgs is as light as it is. We are stuck with the hand nature dealt us. This helplessness is a core component of the cosmic horror feeling. In fiction, the protagonist can fight the monster. In vacuum decay, the monster is the floor, the walls, and the air. There is nothing to fight. There is only the realization of our position. It forces a humility that is rare. In the human species, we are not the masters of the universe. We are squatters in a building scheduled for demolition, hoping the wrecking ball gets stuck in traffic. The expansion of the universe plays a weird role here too. Dark energy is pulling galaxies apart. If the vacuum decays, does dark energy stop? Or does it get stronger? In the true vacuum, the cosmological constant, the energy density of empty space, would likely be different. It could be negative, leading to a big crunch, or it could be enormously positive, ripping the bubble apart instantly. Some theories suggest that the decay of the vacuum is what drives inflation. We might be in a slow-roll inflation phase right now, and the vacuum decay is just the graceful exit from this phase. If so, the end of our universe is just the birth of a new, standard pocket universe. We are the prehistory of someone else's Big Bang. Our apocalypse is their genesis. So what do we do with this information? Do we panic? Do we stop building? No. We do what humans always do. We investigate. We push the boundaries. The discovery of the metastable Higgs hasn't stopped particle physics. It has accelerated it. We want to know the exact shape of the cliff we are standing on. We are designing the future circular collider to smash particles at 100 TeV, 10 times the energy of the LHC. We are sending probes to the edge of the solar system. We are mapping the cosmic microwave background with higher resolution. The threat of annihilation has not paralyzed us. It has galvanized us. It turns out that knowing the universe is fragile makes us want to understand it even more desperately. We are racing the bubble, trying to solve the riddle of existence before the paper is ripped up. The irony is that the tool we use to discover this, the human mind, is itself a fragile, metastable electrochemical pattern. We are mirrors of our universe. Our consciousness can snap just as easily as the vacuum. Yet, in this fragile state, we have managed to deduce the fundamental instability of the cosmos. A species of hairless apes on a small wet rock has managed to look at the invisible fields of the universe and calculate their expiration date. That is a triumph worth noting. Even if the vacuum decays tomorrow, the fact that we knew it could happen is a victory of intelligence over brute matter. We figured out the trap. We might not be able to escape it, but we solved the puzzle. In the face of total annihilation, understanding is the only defiance we have. As we move forward in this investigation, we will look at the other ways the universe tries to kill us: strange matter, rogue black holes, and gamma-ray bursts, but none carry the same ontological weight as vacuum decay. The other threats destroy things in the universe. Vacuum decay destroys the universe itself. It is the ultimate game over. But before we succumb to nihilism, we must remember that metastable can mean stable for a very long time. Diamond is metastable. It wants to turn into graphite, but it takes billions of years. Our universe might be a diamond, under tension, technically unstable, but hard enough to endure. The question is, are we living in a diamond, or are we living in a soap bubble? The investigation continues as we peer deeper into the quantum realm to find the answer. We must turn our attention to the darkest objects in the cosmos, for they may serve as the catalysts for our destruction. Black holes are not merely trash compactors of matter. They are extreme distortions of space-time, where the laws of physics are stretched to their breaking point. In the vicinity of a singularity, gravity is so intense that it bends the very fields that permeate the vacuum, potentially twisting the Higgs field out of its metastable state. Theoretical calculations suggest that the event horizon of a black hole could act as a nucleation seed, a microscopic impurity in the glass of the universe where the crack begins to form, just as a supercooled liquid will instantly freeze if a single dust particle is introduced. the supercooled false vacuum of our universe might snap into the true vacuum around the chaotic geometry of a black hole. If this is true, every black hole is a loaded gun pointed at the heart of reality, and the universe is filled with billions of them. The danger increases as black holes die. According to Stephen Hawking, black holes are not eternal. They slowly evaporate over time, bleeding energy into the void in the form of Hawking radiation. As they lose mass, they get hotter and hotter, their temperature rising inversely to their size. In the final moments of a black hole's life, it becomes microscopic and unimaginably hot, releasing a burst of high-energy particles that dwarfs the output of our most powerful particle accelerators. This localized thermal spike could provide exactly the kick needed to push the Higgs field over the energy barrier. We have not yet observed a black hole evaporating, because the process takes eons for massive ones. But primordial black holes, tiny remnants from the Big Bang, might be exploding right now. Each explosion is a roll of the cosmic dice, a thermal fluctuation testing the stability of the vacuum wall. This connection between black hole thermodynamics and vacuum stability creates a terrifying synergy between the two most destructive concepts in physics. If the universe is filled with primordial black holes, as some dark matter theories suggest, then the vacuum is being assaulted by trillions of tiny exploding heaters every second. The fact that we are still here suggests one of two things. Either primordial black holes do not exist, or the vacuum is more robust than our current math predicts. However, there is a third option: the mutually assured destruction of physics. It is possible that the extreme gravity of the black hole actually stabilizes the vacuum locally, creating a protective shell around the singularity. But as the black hole evaporates and gravity weakens, that protection vanishes precisely when the temperature spikes, exposing the naked vacuum to the ultimate thermal shock. While vacuum decay is the ultimate threat, there is another form of contagious cosmic destruction that mirrors it: the terror of strange matter. Deep inside the crushed cores of neutron stars, the pressure is so high that protons and neutrons might melt into their constituent quarks. Under these extreme conditions, a new type of matter called strangelets could form, consisting of up, down, and strange quarks bound together. This matter is hypothesized to be the, quote, true ground state of baryonic matter, meaning it is more stable than the protons and neutrons that make up your body. If a microscopic piece of strange matter were to escape a neutron star and drift into a normal star or planet, it would act exactly like the vacuum bubble. It would convert the normal matter it touches into more strange matter, releasing energy and growing exponentially. This ICE-9 scenario for matter is functionally identical to vacuum decay for space. In both cases, the universe is currently in a state that is not the most stable configuration, and nature relentlessly seeks stability. If a strangelet struck Earth, it would not blow it up. It would convert the entire planet into a hot, rock-sized lump of strange matter within minutes. The difference is that while vacuum decay travels at the speed of light and rewrites the laws of physics, strange matter conversion travels at sublight speeds and simply rewrites chemistry. It is a slower, messier version of the apocalypse. We search the skies for strange stars, neutron stars that have been fully converted, to see if this contagion exists. If we find one, it proves that the contagion is real, and that the universe contains seeds that can turn our world into dead, hyperdense sludge. The great filter of the Fermi paradox looms large over these theories. We look out into a galaxy that is 13 billion years old and see no galaxy-spanning civilizations, no Dyson spheres, and hear no radio signals. Why? Perhaps the answer lies in the inevitability of high-energy physics. Any civilization intelligent enough to build a starship is also intelligent enough to build a particle collider. As they push the frontiers of knowledge, they inevitably reach the energy levels required to probe the vacuum instability or create strange matter. It is a cosmic trap. The very curiosity that drives a species to the stars is the same curiosity that triggers their deletion. We might be alone, because every other class of students in the cosmic school blew up the laboratory before graduating. The silence of the void is not empty. It is the quiet of a graveyard where the tombstones have been erased. This presents a disturbing solution to the Fermi paradox: technological suicide. It implies that there is a maximum level of technological advancement allowed by the laws of physics before the safety rails break. We assume that knowledge is power, but in a metastable universe, knowledge is danger. We are currently racing toward higher energy experiments, driven by the belief that understanding the universe allows us to control it. But if the control panel is rigged with explosives, our frantic button mashing is not progress. It is a countdown. The Great Silence might be the sound of civilizations hitting the wall of vacuum decay, one by one, blinking out of existence as they reach the pinnacle of their scientific achievement. The vastness of the universe essentially guarantees that if vacuum decay is possible, it will happen. Even if the probability is 1 in a trillion per year per cubic light year, the universe is billions of light years across and billions of years old. When you multiply a tiny probability by a massive volume and a massive time frame, the result approaches certainty. This leads to the terrifying conclusion that there are likely bubbles expanding in the unobservable universe right now. They are eating galaxies we will never see, erasing histories we will never know. We are like a hiker walking through a forest, unaware that a fire has started miles away. The only thing protecting us is the sheer distance and the expansion of space, which might carry the fire away from us faster than it can burn toward us. This brings us to the concept of cosmic censorship. In general relativity, singularities are usually hidden behind event horizons, preventing their naked absurdity from infecting the rest of the universe. Perhaps there is a similar mechanism for vacuum decay, a cosmological censorship that prevents us from ever seeing the bubble. Because the wall travels at the speed of light, we can never observe it coming. We can never study it. We can never learn from it. The universe censors the event by making the death instantaneous. No signal can outpace the destruction to warn us. This ensures that no civilization can ever transmit the data of its own demise to its neighbors. We are all isolated in our ignorance, unable to share the most important discovery we will ever make. Because the act of discovery is the act of destruction. But what if we are just one bubble in a foam of infinite bubbles? The theory of eternal inflation suggests that the multiverse is a continuously expanding medium, where vacuum decay events are the birth pangs of new pocket universes. In this view, our Big Bang was just the result of a vacuum decay in a previous, higher energy universe. We are living inside the aftermath of someone else's apocalypse. This implies an infinite hierarchy of universes, nesting dolls of destruction and creation. While this grants the cosmos a form of immortality, it renders our specific universe, and everything in it, disposable. We are just a transient phase, a momentary fluctuation in an eternal, boiling froth of quantum possibilities. Our stability is a temporary illusion, a brief pause in the cascading waterfall of energy states. If we are living in a multiverse, we must ask if our bubble has ever collided with another bubble. These bubble collisions would leave circular scars on the cosmic microwave background radiation, bruises on the skin of the early universe. Cosmologists search for these patterns today. Finding one would prove that we are not alone, that there are other vacuums out there pressing against ours. But it would also be a terrifying confirmation of the bubble theory. If we can bump into other universes, it means our walls are not impenetrable. A collision with a bubble of a lower energy state would be catastrophic, causing our vacuum to collapse into theirs. We would be invaded by a different physics, overwritten by the laws of a stronger, more stable reality. It is a cosmic game of territorial conquest, where the weapon is the fundamental nature of space itself. There is a mysterious cold spot in the cosmic microwave background, a vast region of the sky that is significantly cooler than it should be. Standard cosmology struggles to explain it. Some theorists propose that this is the bruise we are looking for, the imprint of a collision with a parallel universe billions of years ago. If this is true, we have already survived one encounter with the multiverse. But it also implies that the space beyond our observable horizon is crowded. We are not drifting in an infinite void. We are jostling in a crowded elevator of universes. The cold spot stares down at us, a silent testament to a violent past and a warning that the barriers between realities are not as solid as we think. It is a scar on the face of the cosmos that whispers of things bigger than our entire universe. Let's discuss dark flow, another anomaly where galaxy clusters seem to be streaming toward a specific point in the sky, pulled by something massive beyond the edge of the observable universe. Standard cosmology says matter should be distributed evenly, so there should be no preferred direction. But the data shows a flow. This could be the gravitational pull of a neighboring bubble universe, a massive structure outside our space-time, dragging us toward it. Imagine the horror of realizing that our entire universe is sliding across a cosmic table, being pulled toward an edge we cannot see. We are drifting toward a great attractor that might not be made of matter, but of a different vacuum energy entirely. We are caught in a current that flows out of our reality and into something else. The interplay between dark energy and vacuum decay leads to the Big Rip scenario. If dark energy gets stronger over time, phantom energy, it will eventually tear apart galaxies, stars, and atoms. But before it rips the atoms, it might rip the vacuum itself. The tension in the fabric of space could become so high that it snaps, triggering the vacuum decay. In this scenario, the acceleration of the universe is the winding of a clock spring that will eventually break. We are speeding up, rushing away from each other, stretching the canvas of reality until it tears. The Big Rip and vacuum decay might race each other to the finish line. Either space tears apart, or it snaps into a new configuration. Both outcomes result in a universe where the concept of location becomes meaningless because the geometry required to define it has been destroyed. We must also face the Boltzmann brain paradox again, but through the lens of entropy. In a vacuum that lasts forever, random fluctuations will eventually assemble atoms into a brain that thinks it is you, complete with your memories. If the universe lasts long enough, these freak observers should vastly outnumber real biological observers who evolved. The fact that you perceive an orderly universe suggests that we are not Boltzmann brains, which implies the universe does not last forever. Something must kill the universe young, before it fills up with these hallucinations. Vacuum decay provides the perfect executioner. It ensures the universe dies before it goes senile and fills with madness. Our existence as biological beings might be proof that the vacuum is unstable, because in a stable, eternal vacuum, we would be statistically outnumbered by ghosts. The proton decay experiments add another layer of fragility. We build massive tanks of water underground, waiting for a single proton to fall apart. Standard physics says protons are stable forever. Grand unified theories say they eventually decay. If protons decay, then matter itself is metastable. Given enough time, all the atoms in your body, the Earth, and the stars will simply dissolve into radiation. Vacuum decay is the macroscopic version of this. It is the universe dissolving. Whether it is the particle rotting from the inside or the space rotting from the outside, the message is consistent. Permanence is an illusion. We are temporary patterns in a medium that wants to be uniform. Nature abhors structure. It tolerates it for a while, but eventually it smooths everything out. Consider the timeline of the far future if the vacuum doesn't decay. We enter the black hole era, where the only light comes from the Hawking radiation of dying black holes. Then, the dark era, where only photons and leptons remain, drifting in a void so vast that they never interact. This is the heat death, a state of maximum entropy. It is a fate of infinite boredom. Vacuum decay, by comparison, is a fate of violent transformation. Some physicists argue that a stable universe is actually the nightmare, an eternity of nothingness. The false vacuum, with its hidden energy, at least holds the promise of action. It is a loaded gun, and a loaded gun is more interesting than an empty box. We fear the bang, but the silence of the heat death is its own kind of horror. Is our universe a simulation? The vacuum decay theory aligns disturbingly well with the idea of a computer crashing. In a simulation, parameters are set by the programmer. If the system runs out of memory or hits a stack overflow, it crashes. Vacuum decay looks exactly like a blue screen of death for the cosmos. It spreads at the maximum processing speed, light speed, overriding the complex data with null values. The fine-tuning of the Higgs mass to the edge of instability might be an optimization trick by the simulators, running the hardware at maximum efficiency right on the edge of failure. We might be living in an overclocked universe, pushed to its limits to render complex life, and the instability is the price we pay for the performance. The concept of false vacuum was popularized by Sidney Coleman in the 1970s, calling it the ultimate ecological catastrophe. Unlike an asteroid that kills a planet or a supernova that kills a solar system, this kills the potential for life. It sterilizes the future. It is a crime against time itself. In a universe that decays, nothing that happens matters because no record can be preserved. If you burn a book, the ash remains. If the vacuum decays, the ash is a physics where the concept of a book cannot exist. It makes our struggle for immortality, our art, our archives, our children, feel pathetically small. We are shouting into a canyon that is about to close shut. But what determines the speed of the transition? It depends on the width of the barrier in the energy graph. If the barrier is thick, tunneling is rare. If it is thin, tunneling is frequent. The barrier's thickness is determined by the coupling constants of the standard model. We are currently trying to measure these constants to the umpteenth decimal place. We are essentially trying to measure the thickness of the wall of our prison cell to see if we can dig through it, or if something is digging in. Every time a particle physicist improves the precision of a measurement, they are sharpening the image of our doom. We are not just exploring nature, we are auditing the structural integrity of reality. The quantum Zeno effect suggests that a system cannot change while you are watching it. A watched pot never boils. Could our observation of the universe be stabilizing it? By constantly measuring the particles in the fields, are we forcing them to stay in the false vacuum state? This solipsistic view places the burden of cosmic survival on our consciousness. If we stop looking, does the wave function collapse into the true vacuum? It frames consciousness not as a passive observer, but as the active pillar holding up the roof. Of course, the universe existed before us, but perhaps the emergence of observers locks the vacuum into its current state. We might be the glue holding the cracks together simply by acknowledging they exist. Let's discuss the iron star era. In the incredibly distant future, if vacuum decay doesn't happen, quantum tunneling will fuse all atoms into iron. Stars will become cold balls of iron. Then, over $10 carat $65 years, these iron stars will tunnel into black holes, which will then evaporate. The timescales are nauseating. The human mind cannot comprehend numbers this large. Vacuum decay short-circuits this eternity. It effectively renders the long future irrelevant. We treat the future as an infinite canvas, but vacuum decay cuts the canvas to a finite size. It imposes a deadline on eternity. It forces us to reckon with the idea that forever is a mathematical concept, not a physical reality. There is a curious relationship between the Higgs field and the early universe's inflation. It is possible that the Higgs field played a role in the rapid expansion of the Big Bang. If so, it has already caused one massive phase transition. The fact that it stopped in a metastable state might be a hangover from that violent party. The universe expanded so fast it got stuck on a ledge. We are living in the aftershocks of the creation event. The ground is shaky because it hasn't finished settling from the earthquake of Genesis. We assume the Big Bang is over, but in terms of field settling, we might still be in the final, sputtering moments of the explosion, watching the dust settle, unaware that the floor is about to give way. The information loss paradox in black holes asks where the information goes when a black hole evaporates. Vacuum decay solves this by destroying the context of the information. It doesn't matter if the book is burned if the language it is written in is deleted. The true vacuum might not support the concept of information encoded in matter. It might be a state of pure, uniform energy where distinction is impossible. This is the ultimate entropy. Information requires contrast, a 1 and a 0. Vacuum decay smears the 1 and the 0 into a single indistinguishable value. It is the heat death of meaning. If we could communicate with a civilization in the true vacuum, what would they say? To them, our universe is the anomaly. A high-energy, frantic, unstable bubble that popped into existence and needs to be corrected. They might view the expansion of their bubble into our space not as destruction, but as healing. We are the cancer, the true vacuum is the cure. We are the deviation from the norm. Our complex, struggle-filled lives are just a fever dream of a sick universe. This perspective shift creates a true cosmic horror. The realization that we are not the heroes of the story, but the infection. Let's focus on the scale of the energy release. The energy density of the false vacuum is immense. If a bubble the size of a light bulb formed, it would release enough energy to vaporize the solar system. The sheer density of potential energy in empty space is one of the hardest things to grasp. You are walking through a field of explosives every day. The air in front of your face contains enough latent energy to unmake the world. We are separated from this energy by a quantum wall thinner than a ghost. It makes the solidity of matter feel like a joke. We are hollow shells floating in a sea of fire, protected only by the surface tension of the vacuum. The Standard Model is often called the theory of almost everything. It explains all particles and forces except gravity. The fact that it predicts doom might be its flaw. It is possible that the new physics we are searching for, superstrings, loop quantum gravity, contains the safety mechanism. Maybe there is a rigidity to space-time that the Standard Model misses. We are like ancient sailors predicting the edge of the world because our maps stop, unaware that the world is round. Our prediction of vacuum decay might just be the edge of our map, not the edge of reality. We are terrified by the extrapolation of our own ignorance. But what if the new physics makes it worse? What if we find that the vacuum is even more unstable than we thought? Some extensions to the Standard Model introduce new scalar fields that can also decay. We might be living in a house of cards where every card is a different field. Higgs, inflaton, dilaton, all waiting to fall. The more we learn, the more precarious our position seems. It is a race between discovering the safety mechanism and discovering new ways to die. Science does not always bring comfort. Often, it brings clarity to the danger. We have to consider the survivor bias of the multiverse again. If there are infinite universes and 99.9% of them decay instantly, then 100% of the observers will find themselves in the 0.1% that are metastable. We are amazed by our luck, but we shouldn't be. You can only ask, why am I here in a universe that allows you to be here? This doesn't mean we are safe. It just means we are in the slow lane of the slaughterhouse. We are the ones who haven't been processed yet. The fact that we exist proves nothing about our future longevity, only our past luck. The visual of the purple sky is often associated with vacuum decay in art, likely due to the high-energy photons released at the boundary. If you saw the sky turn violet, it would be the blue-shifted radiation of the incoming wall. But physically, you wouldn't see it. The radiation arrives with the wall. The artistic representation is a comforting lie, giving us a moment of realization. The reality is simpler: light, then dark; presence, then absence. The universe doesn't do dramatic foreshadowing. It just executes the code. Is there a way to escape? Could we build a ship that travels faster than light to outrun the bubble? Current physics says no. Warp drives, if possible, might allow us to surf the wave or punch into a new universe, but they require negative energy, exotic matter that might trigger the vacuum decay we are trying to escape. Paradoxically, the technology needed to save us is the same technology that endangers us. To build a warp drive is to manipulate the vacuum energy. It is like trying to put out a fire with gasoline. The trap is perfect. Any attempt to manipulate the structure of the cage strengthens the mechanism of the trap. Let's talk about the top quark again. It is the heaviest particle, interacting most strongly with the Higgs. Why is it so heavy? It weighs as much as a tungsten atom. It is a point particle with the mass of a nucleus. This absurdity is the root of the instability. If the top quark were lighter, the vacuum would be stable. It feels like a mistake in the design. A glitch. Or perhaps a deliberate self-destruct mechanism. If the universe was designed by a creator or a simulation, the top quark is the kill switch. It is the component that ensures the system doesn't run forever. We are currently observing the universe during the stelliferous era, the era of stars. This is the prime of the universe's life. Vacuum decay threatens to cut this prime short. It feels tragic because of the wasted potential. Trillions of stars that will never be born. Galaxies that will never merge. It is a theft of the future. But the universe has no concept of waste. Energy is conserved or transformed. The true vacuum might be teeming with a different kind of potential. Potential that doesn't involve matter or time. We mourn the loss of the painting, but maybe the canvas wants to be blank again. The doomsday clock of the Bulletin of the Atomic Scientists measures human threats. We are at 90 seconds to midnight, but the cosmic doomsday clock has no hands we can see. We don't know if we are at 90 seconds or 90 billion years. This uncertainty is the defining feature of our existence. We build our lives on the assumption of tomorrow, but tomorrow is a hypothesis, not a fact. Vacuum decay is the ultimate reminder that we are living on faith. Faith in the consistency of physical laws that we barely understand. There is a theory that the Big Bang was actually a white hole, the other side of a black hole. If so, our universe is the interior of a singularity. Vacuum decay might be the evaporation of that singularity. As the parent black hole evaporates, our universe dissolves. We are linked to the fate of a universe completely outside our perception. We are the internal organs of a dying beast. When the beast dies, we vanish. We are not independent, we are contingent. What about the void regions of space? We discussed how KBC voids are empty. Are they safer or more dangerous? Voids have less matter, so fewer black holes and cosmic rays to trigger the decay. But they also have less gravitational binding energy. Maybe the decay starts in the voids, in the silent, empty places where the vacuum is stretched thin. The danger might not be in the fiery centers of galaxies, but in the cold, lonely dark between them. The nothingness might be the birthplace of the ultimate nothingness. The God particle was a nickname given to the Higgs boson by Leon Lederman, originally the goddamn particle, because it was hard to find. The media loved it. But in light of vacuum decay, the name takes on a sinister tone. It is the particle that holds the power of creation and destruction. It is the arbiter of reality. It gives, and it can take away. We found God, and it turns out he is holding a detonator. The religious metaphors are unavoidable because we are dealing with eschatology, the study of the end of all things. Let's consider the geometry of the expanding bubble again. It expands at light speed, but space is expanding too. If the universe enters a phase of phantom energy where expansion accelerates to infinity, it might rip the bubble apart before it consumes us. This is the big rip versus vacuum decay fight. Can the universe expand fast enough to outrun its own death? It is a race between two apocalypses. One tears us apart, the other erases us. We are cheering for the expansion, hoping it keeps the monsters at bay, even though the expansion itself is a slow killer. We have to accept that our intuition about probability fails at cosmic scales. A 1 in a trillion chance sounds safe, but if you roll the dice a trillion times a second for 13 billion years, 1 in a trillion happens every day. The fact that it hasn't happened yet implies that the probability is much, much lower, perhaps 1 in $10 carat, $100. Or it implies that it has happened billions of times, but the bubbles are all far away. We might be in a Swiss cheese universe where the holes are expanding, and we just happen to be in the cheese. The psychological impact of this theory is a form of cosmic vertigo. It is the feeling of the ground falling away. It aligns with the feeling of falling through a KBC void. We are unmoored. We are not standing on solid rock. We are standing on a wave of probability. The solidity of the world is a trick of the senses. Quantum mechanics revealed the trick, and now we can't unsee it. We are ghosts walking through a hologram that is glitching. If we could see the Higgs field, what would it look like? It would be a shimmering, vibrating ocean filling the room. Every time you wave your hand, you are pushing through it. It is dragging on your electrons. It is intimate. It is inside you. The potential for destruction is literally in your blood. Every atom in your DNA is held together by the field that wants to kill you. You are made of the bomb. The danger is not out there, it is the stuff you are made of. Scientific progress acts as a flashlight in a dark room. We turn it on to see where we are, and we reveal the monsters in the corner. Vacuum decay is the monster revealed by the standard model. We could turn the flashlight off, stop doing physics, stop asking questions, but the monster would still be there. Ignorance does not stabilize the vacuum. We are committed to the path of discovery, even if it leads to the discovery of our inevitable doom. We are the species that looks. There are parallels to the gray goo scenario in nanotechnology, tiny robots replicating until they consume the Earth. Vacuum decay is quantum gray goo. It consumes the vacuum state and replicates the true vacuum. It is the ultimate contagion. The universe is a petri dish, and the phase transition is the mold. Once it starts, it grows until the nutrients, potential energy, are exhausted. We are just the bacteria on the agar plate, waiting to be overrun. Can we survive in the true vacuum? Probably not as biological entities. But could intelligence survive? Could we upload our minds into a substrate that operates on the new physics? If the transition is instant, we have no time to adapt. But if we could predict it, if we knew the date, maybe we could prepare. Maybe we could build arches that can weather the storm. But since the wall moves at light speed, prediction is impossible. We are denied the opportunity to prepare. We are denied the dignity of a struggle. The only warning we might get is from neutrinos. Neutrinos travel slightly slower than light, or at light speed, practically. If a bubble formed nearby, maybe a blast of neutrinos would arrive a fraction of a second before the wall. A sudden spike in detectors worldwide. A momentary blip of data that no human could react to, but an AI might register. The computers would know we were dead a millisecond before we did. The logs would show the end of the world, and then the logs would vanish. Let's consider the false vacuum as a battery. The universe is a charged battery. It has stored energy. Life exists by tapping into energy flows. But vacuum decay is the battery short-circuiting. It releases all the energy at once. It is the most violent discharge possible. We are living inside a charged capacitor, marveling at the sparks, ignoring the fact that the dielectric is failing. The energy that allows us to live is the same energy that threatens to burn us. We must return to the concept of nothing. We think we know what nothing is, empty space. But the vacuum is something. It has weight, energy, and structure. Vacuum decay is the transition to a different kind of nothing. It forces us to redefine empty. The void is not a void. It is a substance. And like any substance, it can freeze, boil, or break. We are walking on ice, and we just heard a crack. The search for exotic matter might hold the key. Negative mass, wormholes, these require manipulating the vacuum. If we ever build a wormhole, we might inadvertently puncture the false vacuum. The sci-fi dream of faster-than-light travel might be the trigger. Every drive system we imagine, Alcubierre drives, warp gates, stresses the fabric of space. We might be shaking the vending machine to get a candy bar, only to have the machine tip over and crush us. The dark forest theory says civilizations hide to avoid being destroyed by others. The glasshouse theory says civilizations hide because they are afraid of breaking their own reality. We are throwing rocks in a glass house. We are broadcasting our location and smashing particles together. We are the noisy, reckless neighbors of the galaxy. If there are others out there, they are likely watching us with a mix of pity and terror, waiting for us to make the mistake that ends our silence forever. As we move into the final phase of this investigation, we have established the mechanism, the probability, and the horror of vacuum decay. We have looked at the black holes that might trigger it, and the silence that might result from it. Now we must turn to the future. What happens next? How do we live with this? And is there any scenario, any remote possibility, where we can escape the bubble? We will explore the theoretical life rafts of the cosmos and the ultimate philosophical meaning of a universe that carries its own suicide pill. The speed of light is often romanticized as the ultimate speed limit of the universe, a barrier that challenges our dreams of interstellar travel. But in the context of vacuum decay, the speed of light transforms from a barrier into a cage. Because information cannot travel faster than light, and the bubble of destruction expands at exactly that speed, we are imprisoned in a sphere of ignorance. We cannot see the executioner coming. The light that carries the image of the bubble wall arrives at the exact same instant as the wall itself. This means that if the vacuum collapsed in the Andromeda galaxy 2 million years ago, the wave of death is currently halfway here, silently eating the void between galaxies, and we would simply continue to admire the spiral arms of Andromeda in our telescopes, completely unaware that the galaxy has already ceased to exist. We are looking at ghosts. The universe we observe might already be dead, a hollow shell of light that hasn't yet received the memo of its own destruction. This disconnect between what we see and what currently exists is the ultimate cosmic gaslighting. We trust the sky, but the sky is a time-delayed broadcast of a reality that might no longer be there. Consider the immense energy density locked within the false vacuum. We are taught that E equals mc squared, that matter contains energy. But empty space itself contains energy, and in a metastable state, that energy is essentially a loaded spring. If you could capture the potential energy contained in the volume of a coffee cup of false vacuum and release it, it would be enough to boil Earth's oceans. we are swimming in a sea of unexploded ordnance. The stability of our daily lives, the chemical bonds that hold our DNA together, the nuclear forces that power the sun, relies entirely on this spring not uncoiling. It is a testament to the strange resilience of quantum mechanics that we can exist on top of such a volatile foundation. We are like structures built on a frozen lake of nitroglycerin. As long as the ice holds, we are fine. But the substance beneath us is yearning to release its fury. This latent violence of the vacuum explains why the bubble wall accelerates. It is feeding on the very space it destroys, turning the passive background of our lives into the fuel for our annihilation. There is a profound connection between the stability of the vacuum and the existence of complexity. Complexity, life, consciousness, computers, requires a low entropy state that persists for a long time. If the vacuum were too unstable, it would decay before stars could form. If it were too stable, it might imply a universe with different parameters where complexity is impossible for other reasons, like gravity being too strong. We seem to occupy a Goldilocks zone of instability, stable enough to allow 13.8 billion years of history, but unstable enough to eventually end. This suggests that the conditions required for life are intimately tied to the conditions that threaten it. We are not safe despite the danger. We are here because of the specific high-wire act the universe is performing. The tension in the field that threatens to kill us might be the same tension that allowed the Big Bang to produce a rich, varied cosmos instead of a boring, uniform soup. Our existence is a byproduct of cosmic risk. Let us explore the survivor bias in the context of the many worlds interpretation of quantum mechanics. If the vacuum decays in 99% of all quantum branches, then in those branches there are no observers left to mourn the loss. The only branches that contain observers are the ones where the vacuum hasn't decayed yet. This creates a terrifying illusion of invincibility. We look at our history and say, look, we survived for billions of years, so we must be safe. But this is like a soldier running across a minefield, stepping on 99 duds, and concluding that mines don't explode. The silence of the void is not evidence of safety. It is simply the silence of the survivors who haven't stepped on the live mine yet. As time goes on, the number of surviving branches diminishes. We are becoming statistically rarer with every passing second. We are the lucky few in a multiverse of dead vacuums, mistaking our luck for a law of physics. The odds catch up to everyone eventually, even across infinite timelines. The concept of the Big Slurp, a somewhat whimsical name for vacuum decay, belies the absolute horror of the event. It is not just a physical destruction, it is an ontological reset. When the bubble hits, it doesn't just burn matter, it changes the definition of what matter is. Protons might decay into positrons. Neutrinos might acquire massive weight. The laws of thermodynamics could invert. It is the ultimate Control-Alt-Delete for reality. If a civilization had achieved everything, conquered their galaxy, solved death, built a utopia, the Big Slurp renders it all meaningless in an instant. It makes the struggle for progress feel futile. Why build a sandcastle if the tide is coming? But perhaps this futility is the point. It forces us to find meaning in the act of building itself, rather than the permanence of the result. If the universe is destined to be wiped clean, then the only value lies in the momentary experience of existence. We are creating art on a canvas that will be burned, and that makes the art more precious, not less. We must scrutinize the instruments we use to measure our doom. The Large Hadron Collider, LHC, and the proposed Future Circular Collider, FCC, are our telescopes into the quantum realm. Critics argue that we are playing with fire, that creating high-energy collisions could locally heat the vacuum and trigger the decay. Physicists counter that cosmic rays do this naturally at much higher energies. But cosmic rays hit stationary targets. Colliders smash two beams together head-on, creating a different kind of energy density and quantum state. While the consensus is that we are safe, there is always the unknown unknown. What if there is a subtle resonance effect in the Higgs field that only triggers under specific, artificial conditions? What if we are the first species in the galaxy to build a machine capable of picking the lock of the vacuum? It is a gamble where the stake is the universe and the payout is knowledge. We have decided, as a species, that the knowledge is worth the risk, even if we don't fully understand the odds. The heat death of the universe is a slow fade into black, a whimpering end where entropy wins. Vacuum decay is the Big Bang in reverse, or rather, a new Big Bang. Inside the bubble of true vacuum, the energy released could be sufficient to ignite a new period of inflation. This leads to the dizzying possibility that our destruction is the creation event for a new universe. We are the fuel, the atoms of our bodies, the light of our stars, the fabric of our space. All of it is consumed to power the birth of a successor cosmos. This Phoenix universe theory suggests an eternal cycle of bubbles popping within bubbles, each one feeding on the corpse of its parent. It is a cosmic ecology where universes eat each other to survive. We might be living in the decaying carcass of a previous universe right now, unaware that our Big Bang was just the death of our ancestors. It connects us to an infinite chain of being, but it requires our total sacrifice to continue. Let's visualize the geometry of the bubble wall again. It is a spherical shell of high-energy plasma, expanding at light speed. To an observer inside the bubble, if they could exist, the wall is receding. To an observer outside, it is approaching. But at the exact boundary, space and time are twisted. The wall represents a domain wall, a topological defect in space-time. As it passes through a galaxy, it doesn't push the stars away, it passes through them. The gravity of the wall itself would be immense, creating a tidal force that rips planets apart before the phase transition even hits the atoms. It is a gravitational tsunami followed by a quantum firestorm. The destruction happens on multiple levels simultaneously: gravitational, chemical, and subatomic. It is a total assault on the structure of reality. There is no bunker, no shield, no force field that can stop a domain wall. It is the authority of physics asserting itself over the temporary rebellion of matter. The doomsday argument uses Bayesian statistics to predict the end of humanity. If you assume you are a random human in the total history of the species, you are likely living in the middle of the timeline, not the beginning. This suggests that the total number of humans who will ever live is not infinitely larger than the number who have already lived. Vacuum decay provides a physical mechanism for this statistical limit. If the universe has a shelf life, then humanity has a shelf life. We cannot expand into the stars forever because the stars themselves are sitting on a crumbling foundation. The Great Filter might not be nuclear war or climate change, but the Higgs field. It acts as a hard cap on the longevity of any civilization. No matter how wise, peaceful, or advanced a species becomes, they cannot legislate the stability of the vacuum. We are all subject to the tyranny of the top quark. What defines the true vacuum? Why is it true? In physics, systems seek the lowest energy state. A ball rolls down a hill. Water flows to the sea. The true vacuum is simply the bottom of the hill. Our current vacuum is a ledge. The universe is trying to get to the bottom. This anthropomorphizing of the universe suggests a drive, a desire for rest. The universe is under tension, holding its breath, waiting to exhale. Vacuum decay is that exhalation. The violence of the event is simply the release of billions of years of pent-up tension. It is the universe relaxing into its natural state. We perceive it as a catastrophe because we exist in the tension. We are creatures of the stress. Without the stress in the field, we wouldn't be here. So in a way, we are fighting against the natural order of the cosmos just by existing. We are an anomaly that nature is trying to correct. Scientific uncertainty usually means we need more data. In the case of vacuum decay, uncertainty is the only thing keeping us sane. If the error bars on the top quark mass were smaller, and they confirmed instability, we would have to live with the certain knowledge of our doom. The current ambiguity allows for hope. We can cling to the possibility that the standard model is wrong, that supersymmetry exists, or that dark matter stabilizes the field. We are in the uncomfortable position of hoping that our best scientific theory is broken. We want the standard model to be wrong. Usually, scientists cheer when a theory is confirmed. Here, a confirmation of the standard model is a death sentence. We are rooting for the anomaly, for the ghost in the machine that says, wait, you missed something. We are praying for a flaw in the math that saves the world. The purple haze, often depicted in artistic renderings of vacuum decay, is a representation of the high-energy photons, gamma rays, and X-rays that would be generated at the boundary. While we wouldn't see them, the universe would briefly shine with the brightness of 1 trillion supernovas at the wavefront. This is the flash of the camera taking the final picture of the cosmos. The energy released is the difference between the false vacuum and the true vacuum. If that difference is large, the flash is blinding. If it is small, it might be a silent, dark wave. Calculations suggest the energy difference is significant. It would be a fiery end. The universe wouldn't just go dark, it would go out in a blaze of glory, a final firework display that no one would be around to applaud. It is a spectacle for the void itself. Can we detect the pre-shocks? Some theories of quantum gravity suggest that before a phase transition, there might be precursor fluctuations, tiny bubbles that form and collapse rapidly, creating gravitational ripples. If we had detectors sensitive enough, far beyond LIGO, we might hear the vacuum fizzing before it boils. This fizzing would be the sound of the Higgs field testing the barrier. A rising crescendo of gravitational static could be the 2-minute warning. But what would we do with that warning? We couldn't stop it, we couldn't flee. It would just be a time to make peace with the end. The knowledge would be a burden, not a tool. Perhaps it is better that we are deaf to the fizzing, that we live in the quiet ignorance of the false vacuum until the very end. The interplay with dark energy is critical. Dark energy is pushing galaxies apart. If it continues to accelerate, we eventually reach a state where every galaxy is isolated in its own observable universe. In this scenario, a vacuum decay event that starts in a distant galaxy would never reach us. The space between us would expand faster than the light-speed bubble wall. We would be safe from everyone else's mistakes. But we would still be vulnerable to our own. This leads to a patchwork multiverse where some pockets have decayed and others haven't, separated by expanding gulfs of nothingness. The universe becomes a graveyard with a few lonely islands of life, each waiting for its own internal clock to run out. Isolation becomes the only effective shield against the cosmic contagion. Let's reconsider the strange matter scenario as a parallel. Strangelets are dangerous because they are more stable than normal matter. Vacuum decay is dangerous because the true vacuum is more stable than our vacuum. In both cases, the threat comes from nature seeking a lower energy state. The universe is inherently lazy. It wants to do the least amount of work. Maintaining complex structures like atoms and vacuum energy takes effort in the form of potential energy. The fall to stability is the universe giving up that effort. Entropy is the erosion of distinction. Vacuum decay is the sudden collapse of distinction. It is the ultimate expression of the second law of thermodynamics. It is not an accident, it is the destination. The fact that we have stalled the fall for 13 billion years is the anomaly. There is a theory that black holes might actually be vacuum cleaners. As matter falls in, it is crushed. Maybe the interior of a black hole is a patch of true vacuum. The event horizon protects us from it. But as the black hole evaporates, the horizon shrinks. When it disappears, does the true vacuum inside leak out? Or does it evaporate away into radiation? If black holes harbor the true vacuum, then we are surrounded by sealed containers of the apocalypse. We are studying them, photographing them, unaware that they contain the acid that could dissolve the floor. It gives a new meaning to the phrase event horizon. It is the boundary between our reality and the reality that ends us. The cosmological constant problem is the worst prediction in the history of physics. Theory predicts a vacuum energy $10 caret, $120 times larger than what we observe. This discrepancy is staggering. It suggests we really don't understand the vacuum. If our theory is that wrong about the energy density, how can we trust it about the stability? Maybe the vacuum is far more complex, with layers and gears we can't see. We are like cavemen trying to understand a smartphone. We see the light, the particles, but we don't understand the battery, the vacuum energy. This vast ignorance is the dark ocean we sail upon. The vacuum decay calculation is based on the smartphone theory we have built so far. But if the theory is fundamentally flawed, the prediction could be completely backwards. Maybe the vacuum is rock solid. Or maybe it's already collapsing. What if the universe is cyclic, and life plays a role in the cycle? Some speculative cosmologies suggest that intelligent life eventually evolves to the point where it can manipulate the vacuum. Maybe the purpose of life is to trigger the decay, to reset the clock, to be the midwives of the next universe. In this view, we are not victims, we are the mechanism. The universe grows consciousness, so that consciousness can eventually reach down into the engine room and flip the switch. It recasts our dangerous curiosity as a biological imperative. We build colliders not because we are reckless, but because we are programmed by the cosmos to eventually restart the system. We are the destruct sequence encoded in protein and water. The aesthetic of the end is something to ponder. A wall of light moving at $C$. It would be the most beautiful thing ever seen. For the fraction of a nanosecond you could see it. It is the sublime in its purest form, terror and beauty combined. The universe ending not with a whimper, but with a wave of transformation. It is a cleansing fire. There is a purity to vacuum decay that is absent in other doomsday scenarios. It leaves no wreckage. It leaves no corpses. It is a perfect, clean deletion. It appeals to a certain sense of order. If the universe is a messy equation, vacuum decay is the eraser that wipes the board clean for the next mathematician. But we must fight for our messy equation. We are the variables that make the universe interesting. The false in false vacuum implies something wrong, something fake. But false here just means high energy. It means alive. We live in the false vacuum because the true vacuum is dead. We should wear the label with pride. We are the inhabitants of the high energy state. We are the sparks flying from the live wire. The danger is the price of admission for existence. To be alive is to be unstable. To be stable is to be a rock or a cloud of cold gas. We choose the danger because the danger is life. The search for new physics at the LHC is effectively a search for the structural blueprints of our cage. We are looking for the supersymmetric partners, selectrons, squarks, gluinos. If we find them, they act as pillars, reinforcing the vacuum stability graph. The fact that we haven't found them yet is the source of the anxiety. It is like looking for the support beams in a house and finding only drywall. Where are the beams? Are they hidden or are they missing? The desert hypothesis suggests there are no new particles between the Higgs scale and the Planck scale. If true, the desert is a vast, empty wasteland where the forces of instability can roam unchecked. We are alone in the desert, hoping the wind doesn't blow too hard. Let's assume the vacuum decays. Does time stop? Time is a measure of change. Inside the bubble, if the laws of physics don't allow for atomic processes, does change happen? If the interior is a featureless soup of energy, time might lose its meaning. It becomes a timeless, eternal state. So the moment the wall hits you is the moment you enter eternity. You don't die. You are translated into a state of timeless energy. It is a strange form of afterlife provided by physics. You become part of the background radiation of the new universe. You are recycled. The information that made you is scrambled, but the energy is conserved. You are still there, just unreadable. We are currently standing on the shoulders of giants, Einstein, Higgs, Hawking, trying to see over the horizon. But the horizon is moving. The universe is dynamic. The vacuum we live in today might be different from the vacuum of a billion years ago. Fields can evolve. Maybe the barrier is getting thinner as the universe cools. Maybe we are safer in the past than in the future. This evolution of parameters is a terrifying thought. It means the safety regulations of the cosmos are being deregulated over time. The older the universe gets, the more likely it is to break a hip. We might be approaching the senility of the cosmos, where the bones of reality become brittle. The simulation hypothesis offers a darkly comic solution. Maybe the vacuum decay is just the simulation being shut down. The users are bored. They are pulling the plug. Or maybe they are updating the software. The true vacuum is version 2.0. We are legacy code that is no longer supported. This perspective reduces our existential terror to a software glitch. It makes the universe feel artificial, but it also makes the end feel rational. It is not a tragedy. It is an update. Of course, to the characters in the game, the deletion is indistinguishable from death. What if the bubble wall is permeable? What if, instead of destroying us, it fundamentally alters us? This is the transformation hypothesis. Maybe the new physics allows for a different kind of life. Maybe we become creatures of pure light or silicon-based consciousness. It is unlikely, given the violence of the transition, but it is a sliver of hope. Perhaps the great filter is actually a great threshing floor, separating the grain from the chaff. Only the civilizations that can figure out how to survive the transition get to enter the next level of reality. We are currently failing the test because we haven't even figured out how to leave our planet, let alone our vacuum state. The metastability of the universe is the ultimate sword of Damocles. It hangs by a thread of quantum probability. Every moment of silence is the thread holding. Every sunrise is a reprieve. We should look at the stability of the ground not as a guarantee, but as a continuous active miracle. The universe is balancing a pencil on its tip for 13 billion years. It is a feat of balance that defies expectation. We are the beneficiaries of this impossible balance. We should walk softly, speak quietly, and appreciate the precarious beauty of a world that has no right to exist, yet insists on doing so anyway. As we scan the heavens with James Webb and other telescopes, we are looking for anomalies. A region of space where the stars look wrong, a hole in the galaxy, a zone of silence. These could be the signatures of a bubble that started but stopped, or a bubble that is approaching. We haven't seen one yet. But the universe is big, and our eyes are small. We are scanning the ocean with a drinking straw. The monster could be just outside our field of view. The fact that we haven't seen it is not proof of absence. It is just proof of our limited vision. We are blind watchers in a dark forest. The interaction of gravity and the quantum vacuum is the frontier. Black holes are the testing grounds. If we ever observe a black hole evaporation up close, we might see the vacuum flicker. We might see the sparks. This is why we study the extreme. We need to know where the breaking point is. We are crash testing the universe in our minds because we cannot survive a real crash. The mathematics is our crash test dummy, and right now, the dummy is coming back shattered. The equations are screaming danger. We are trying to find a variable we missed, a seatbelt we forgot to account for. False vacuum sounds like a defect, but maybe it is a feature. A true vacuum universe might be sterile. Maybe only a false vacuum can support the complexity of life. If so, then life and danger are inseparable. You cannot have one without the other. To be alive is to be at risk. This is true biologically, and it turns out to be true cosmologically. The universe made a bargain. I will give you matter, stars, and consciousness, but the price is that the floor might fall out. We are living in the deal. We accepted the terms of service when the first cell divided. Now we are just reading the fine print. The many interacting worlds theory suggests that parallel universes exert a force on each other. If a nearby universe decays, the shockwave might jostle ours. It might bump us off the ledge. We are not isolated. We are packed in a crate with other universes bumping shoulders. If one falls, it might drag the others down. This interconnectedness of the multiverse turns a local problem into a global one. A disaster in Dimension X could be the end of Dimension Y. We are part of a cosmic ecosystem, and if the ecosystem is sick, we are at risk. Let us look at the top quark mass again. 173 GeV. It is the heaviest particle. Why? Does it couple to a sector of physics we don't know? Maybe the top quark is a portal to a hidden dimension. If so, its mass might be an illusion, a projection from a higher space. If the true mass is different, the stability calculation changes. We are basing our panic on the shadows on the wall, not the objects casting them. Plato's cave applies to particle physics. We see the mass, but we don't see the mechanism. Until we see the mechanism, our fear is based on shadows. The standard model is a map. It is the best map we have, but it has blank spots. Here be dragons. Vacuum decay is one of the dragons drawn in the margins. We don't know if the dragon is real or just a doodle by a bored cartographer, a mathematical artifact. But the map has been right about everything else. It predicted the Higgs. It predicted the W and Z bosons. It predicted the top quark. It has a track record of being right. So when it says, "Here be dragons," we should probably listen. The map hasn't lied to us yet. The cosmic background radiation is the afterglow of the Big Bang. It is the oldest light. It tells us the universe was once hot and dense, It proves the universe changes. It evolves. It is not static. If it changed once from hot to cold, it can change again from false to true. The precedent is there. The universe is a shapeshifter. We have only seen one of its forms. We assume this form is the final one, but that is the arrogance of the mayfly, assuming the day will last forever. The universe has more gears than we know. We are currently building detectors for gravitational waves in space, LISA. These will detect the collisions of supermassive black holes, but they might also detect the hum of the vacuum. The background noise of the universe might contain the signature of metastability. If we hear the hum change pitch, we know the tension is changing. We are putting a stethoscope to the chest of the universe. We are listening for the heartbeat of the Higgs field. We hope the rhythm is steady. The vacuum is not empty. It is a medium. It has properties. It can be stressed. It can break. We need to stop thinking of space as a stage and start thinking of it as a material that can shatter. If you hit glass with a hammer, it breaks. If you hit the vacuum with enough energy, it breaks. We are the monkeys with the hammers, colliders. We are testing the strength of the glass. We hope it is bulletproof. But the math says it might be plate glass. And we are swinging harder every year. Nothing lasts forever. This is a platitude, but in physics it is a law. Protons might decay, black holes evaporate, stars burn out. Why should the vacuum be exempt? Everything else in the universe has a lifespan. Why should the container be immortal? The container is made of the same quantum fields as the contents. It is subject to the same rules of decay. The universe is mortal. It was born, it lives, and it will die. Vacuum decay is just one of the ways it can die. It is the sudden infant death syndrome of the cosmos. The bubble is a nucleation event. Like a raindrop forming in a cloud, it requires a seed. What are the seeds? Cosmic strings? Primordial black holes? Magnetic monopoles? The universe might be full of seeds. We haven't found them yet, but theory predicts them. If the universe is dusty with these defects, the nucleation rate goes up. We are hoping the universe is clean. A clean universe is a safe universe. A dirty universe is a minefield. We are currently scrubbing the sky with telescopes, looking for the dirt. The great attractor pulls us, dark flow drags us. We are moving, we are not stationary. We are moving through the cosmic background. Does our motion affect the vacuum? Relativistic effects? Probably not, but it adds to the sense of helplessness. We are being dragged into the unknown. We are passengers on a runaway train, the galaxy, moving at millions of miles per hour through a medium, the vacuum, that might explode. It is a precarious ride. The Boltzmann brain argument again. If the universe ends quickly, vacuum decay, then Boltzmann brains don't have time to form. This solves the paradox, so vacuum decay is actually required to make sense of our existence. If the universe didn't decay, we wouldn't be the ones observing it. The random brains would be. Therefore, the fact that we are biological observers is indirect evidence that the vacuum will decay. Our existence predicts our destruction. We are the canary in the coal mine, and the fact that we are singing means the mine hasn't collapsed yet, but the collapse is mandated by logic. Metastability is like a pencil balanced on its tip. It can stay there if it's perfectly balanced. But the universe is noisy. Quantum fluctuations are the wind shaking the table. How long can the pencil stay up? 13.8 billion years is a long time for a balancing act. It suggests the pencil is very broad, a wide potential well, or the table is very still, low temperature. But we know the table was shaking violently in the past. Big Bang. The fact that the pencil didn't fall then is the miracle. Maybe it fell into a different false vacuum. Maybe we are already in the basement, but there is a sub-basement. The hierarchy problem asks why the Higgs is light. Maybe it is light, because it has to be for us to be here. If it were heavy, the universe would be stable but sterile. No chemistry. If it were lighter, the universe would have collapsed instantly. The value is tuned for life, but the cost of that tuning is instability. It is a Faustian bargain. Life gets to exist, but it has to live on the edge of the abyss. We are the payment for the tuning. We look at the cosmic web, the filaments of galaxies. They look like neurons. Is the universe alive? If so, is vacuum decay a stroke? A brain aneurysm? If the universe is a biological organism on a scale we can't comprehend, then phase transitions might be part of its metabolism. We are just the mitochondria in the cells of a giant beast. The beast might be evolving, changing state. We are terrified of the change because it kills us, but to the beast, it is just growing up. The big crunch was the old fear, the universe collapsing. Vacuum decay is the new fear, the universe transforming. It is a shift from geometric doom to quantum doom. The result is the same, the end of history. But the mechanism is different. One is gravity winning, the other is entropy winning. Both are relentless forces. We are caught between gravity and entropy, the rock and the hard place. We exist in the narrow gap where the two forces balance out for a brief moment. False vacuum implies deception. The universe is lying to us. It looks solid, but it isn't. This theme of cosmic deception runs through modern physics. Holographic principle? The universe is a hologram. Dark matter? The universe is hiding 85% of its stuff. False vacuum? The stability is a lie. We are uncovering the lies one by one. Physics is the process of debunking the universe's con. We are the detectives catching the cosmos in a lie. But this is one lie that, if exposed, ends the investigation. What if the vacuum decay is triggered by dark energy density increasing, the Big Rip scenario? As space expands, if dark energy density goes up, the vacuum gets stressed. Eventually, it snaps. This links the expansion of the universe directly to the stability of the vacuum. The faster we expand, the closer we get to the snap. We are pressing the accelerator, but the engine is overheating. We are racing toward the cliff edge of the energy graph. The standard model is incomplete. We know this. It doesn't explain neutrinos' mass well. It doesn't explain gravity. It doesn't explain dark matter. So why do we trust it about vacuum decay? Because it works so well for the particles we are made of. It explains atoms perfectly, and vacuum decay is about the stability of atoms. So even if the map is missing the edges, the center part, where we live, says danger. We can't dismiss it just because we don't know what dark matter is. The part we do know is the part that is threatening us. Safety is a biological concept. It doesn't apply to physics. Atoms don't care about safety. Stars don't care. Only we care. We are projecting our desire for permanence onto a universe that is built on change. We want the universe to be a home, but it is a process. Processes end. Reactions finish. We are inside the reaction. We are the catalyst or the byproduct. We are not the owner of the lab. We are just the chemicals bubbling in the beaker. The LHC runs at 13 TeV. We want 100 TeV. The universe runs at $10 carat, $19 TeV, Planck scale. We are children playing with matches compared to the forest fire of the Big Bang. But matches can start forest fires. The concern is not the total energy, but the energy density. If we create a spot, hot enough, dense enough, we might pierce the veil. We are poking the dragon with a needle. It is a small needle, but if you poke the wrong spot. Vacuum decay is the ultimate unknown unknown turned into a known unknown. We know it can happen, we just don't know when. It is a sword of Damocles that we discovered ourselves. We forged the sword by doing the math. Before 2012, we didn't know. Now we know. Ignorance was bliss. Knowledge is terror. But we cannot unknow it. We have to live with the sword. As we enter the final chapter of this exploration, we must look beyond the doom. We must look at the meaning. If the universe is temporary, what does that make us? Are we less significant? Or more? If the play only has one performance, does that make the acting more important? We will conclude by looking at the philosophy of the end and the strange hope that lies in the face of total annihilation. The human mind is equipped with a powerful defense mechanism against existential dread, the ability to normalize the impossible. We walk around on a planet spinning at 1,000 miles an hour, orbiting a nuclear explosion, drifting through a galaxy filled with black holes, and we worry about traffic. This trivialization of the cosmic scale is necessary for our sanity. If we truly internalized the reality of vacuum decay, if we felt the precariousness of the Higgs field in our bones, we would be paralyzed. We would be unable to build, to love, or to plan. So we treat the vacuum instability as a distant abstraction, a ghost story for physicists. But the ghost is real. The mathematics describing the instability is the same mathematics that allows your phone to work and the sun to shine. You cannot cherry-pick the laws of physics. If you accept the science that gives you technology, you must accept the science that predicts the apocalypse. The universe is a package deal, and the package includes a self-destruct mechanism. Our normalcy is a thin veneer painted over a deep, terrifying truth. We are living on a battlefield where the war hasn't started yet, or perhaps where the war is already over and the shockwave just hasn't reached us. Let us look at the Future Circular Collider, FCC again. The scientific community is divided. Some say it is too expensive, others say it is essential. But in the context of vacuum stability, it is the most important machine ever conceived. It is the only way to refine the measurement of the Higgs self-coupling parameter. This parameter tells us the shape of the potential energy curve with precision. Right now, we are squinting at a blurry map. The FCC would hand us a magnifying glass. It would tell us if the ledge has a lip, or if it is a smooth slope downward. The decision to build it is a decision to confront our fate. It is a decision to look the Medusa in the eye. If we build it and find out the vacuum is unstable with a lifetime of only 1 billion years, how does that change human civilization? Does it create a global nihilism? Or does it unite us in a desperate bid to survive? The sociology of the answer is as fascinating as the physics. We are not just measuring a particle, we are measuring the expiration date of our species. There is a concept in philosophy called cosmic indifference. The universe is not hostile, it is indifferent. Vacuum decay is the ultimate expression of this indifference. A hostile universe would try to kill us. An indifferent universe simply changes state, and our death is collateral damage. The Higgs field does not want to decay, it just follows the path of least resistance. This lack of malice makes the horror pure. There is no villain to hate. There is no dark lord to defeat. There is just a ball rolling down a hill. The fact that the ball crushes civilization is irrelevant to the ball. This stripping of agency from the narrative of our destruction is deeply unsettling. We want to be the heroes of a tragedy, but we are just dust on a collapsing stage. We are irrelevant to the mechanics of the transition. The vacuum was here before us, and the true vacuum will be here after us. We are a momentary fluctuation in the history of a field. Consider the great silence of the universe again. The Drake equation predicts thousands of civilizations. We see zero. The vacuum instability solution suggests that civilizations are essentially suicide pacts. As soon as they learn enough physics to manipulate the vacuum, they accidentally trigger the decay. This would mean that intelligence is a self-limiting property. It evolves, it learns, it builds a collider, and it pops the bubble. We might be the only ones left because we are the slow class. We haven't figured out how to break the toy yet. This paints a dark picture of the future of science. Is there a forbidden knowledge? Is there a theorem that, once proven, destroys the prover? It suggests that the path to the stars is mined with traps that only the smartest can trigger. We are currently walking through the minefield, proud of our intelligence, unaware that our intelligence is the trigger mechanism. The many worlds interpretation suggests that every time a quantum event happens, the universe splits. This means that in the multiverse, vacuum decay is happening constantly. Somewhere, right now, a version of Earth is being vaporized by a wall of true vacuum. We are the survivors of a continuous, infinite slaughter. We only exist in the branches where the decay hasn't happened yet. This quantum survivorship implies that we are destined to witness the end eventually, or to be the last ones standing in a dying multiverse. We are the beneficiaries of an infinite chain of near misses. Every second you breathe is a second where the dice didn't come up snake eyes in your specific branch of reality. We should feel a profound sense of gratitude, or perhaps a profound sense of vertigo, knowing that we are walking a tightrope over an infinite graveyard of dead universes. Let's talk about the bubble nucleation rate again. It depends exponentially on the barrier height. A small change in the height leads to a massive change in the lifetime of the universe. If the barrier is just a tiny bit lower than we think, the lifetime drops from $10 carat $100 years to $10 carat $10 years. We are currently at $1.38 times 10 carat $10 years. We might be nearing the end of the warranty period. The difference between safe forever and doomed tomorrow is microscopic in the equations. We are hanging our hopes on the decimal places. This is why precision physics is an existential endeavor. We are not just collecting stamps. We are reading the terms and conditions of our lease on existence. And the print is very, very small. What if the vacuum decay is slow? Some theories suggest that the wall might move slower than light. If so, we could see it. We would see a hole in the sky, a region of absolute blackness, or weird distortion, growing larger every night. It would be a slow-motion apocalypse. We would have years to watch the stars disappear one by one. We would calculate the exact date of impact. Society would collapse long before the wall hit. The anticipation would be the killer. We would build monuments, launch time capsules, and scream into the void, knowing that the void is coming to eat the scream. This slow decay scenario is arguably worse than the fast one. It gives us time to dread, but no time to escape. It turns the end of the world into a spectator sport where we are the audience and the victims. The cosmological constant is positive. The universe is accelerating. This means galaxies are moving away from us. Eventually, they will cross the cosmic horizon and disappear. If a vacuum bubble forms beyond the horizon, we will never see it, and it will never reach us, assuming space expands fast enough. This is the safety by isolation theory. The lonely darkness of the far future might be our shield. We will be alone, trapped in our own observable patch, but we will be safe from the mistakes of distant civilizations. The fragmentation of the universe into isolated pockets protects the whole from a single catastrophe. We are quarantined by dark energy. The expansion of space is the firewall that stops the virus of vacuum decay from infecting the entire multiverse. But what if dark energy decays? If the field driving the expansion is also metastable, it could decay into a different form. It could turn into attractive gravity, leading to a big crunch. In a collapsing universe, all the vacuum bubbles would eventually merge. The quarantine would fail. The walls would come closing in. We would be squeezed into a smaller and smaller volume, forced to confront the decay bubbles we thought we had escaped. The end of the universe would be a chaotic mix of crushing gravity and dissolving vacuum. It would be a messy, hot, violent end. The Big Crunch combined with vacuum decay is the ultimate chaotic finale. It ensures that nothing survives. No information, no matter, no memory. It is the perfect erasure. We assume that the true vacuum is uninhabitable. But what if it isn't? What if it supports a chemistry we can't imagine? Maybe the bubble wall is a transformative wave that upgrades the universe. We are the caterpillars, and the vacuum decay is the chrysalis phase. We dissolve, but something else emerges. This optimistic nihilism suggests that the destruction of our form is necessary for the emergence of the next form. We are holding on to our specific configuration of atoms, thinking it is the pinnacle of creation, but the universe might have better plans. We are fighting the upgrade. Of course, this is cold comfort to the caterpillar that dissolves, but it gives a sense of purpose to the cosmos. It suggests that the universe is evolving towards something, rather than just dying. The Standard Model has held up for 50 years. It withstood every test. It is the most robust theory we have, and it predicts potential doom. We have to respect the prediction. We cannot pick and choose the parts of science we like. We like the part that gives us MRI machines and transistors. We dislike the part that says the universe is a trap, but it is the same theory. To reject vacuum decay is to reject the foundation of modern physics. We are forced into a position of scientific fatalism. We trust the math, and the math says the ground is shaking. We have to live with the cognitive dissonance of trusting a system that predicts our inevitable demise. Let's consider the simulation idea one last time. If the universe is a simulation, vacuum decay is a buffer overflow. It is the system crashing because it ran out of memory. Or maybe it is a garbage collection routine. The system deletes unused sectors to save processing power. We are the unused sector. We are the temporary cache files that are about to be purged. This view strips the universe of its mystical grandeur and reduces it to a computational process. It makes our end mundane. We are not tragically destroyed. We are simply cleared from the RAM. It is a bureaucratic apocalypse. The top quark mass is the key. Why is it so heavy? It interacts with the Higgs field more strongly than anything else. It is the anchor that drags the vacuum down. If we could change the mass of the top quark, we could save the universe. But we can't. The constants of nature are fixed. We are locked in a cage with a heavy weight that is slowly breaking the floor. We can measure the weight, we can name it, but we cannot move it. The immutability of physical laws is the source of the tragedy. We are smart enough to understand the trap, but not powerful enough to disable it. We look at the cosmic microwave background, CMB for SCARS. If our universe is a bubble that formed in a previous universe, the CMB is the echo of that birth. If we find circular patterns in the CMB, it proves the bubble theory. It proves that universes are born from decay. This would confirm that our Big Bang was just a vacuum decay event in a parent universe. It connects our beginning to our end. We were born from destruction, and we will die by destruction. It is a symmetry that is aesthetically pleasing but existentially terrifying. It means the universe is a cannibal, eating itself to be reborn. The concept of Boltzmann brains suggests that in the far future, random fluctuations will create conscious minds. If vacuum decay happens, it stops this. It prevents the universe from becoming a hallucination factory. In a weird way, vacuum decay protects the sanctity of reality. It ensures that the only observers are biological ones who evolved, not random fluctuations. It keeps the universe honest. It is a hard reset that prevents the cosmos from descending into senile madness. It is the universe choosing death over insanity. Metastability implies a timescale. Is it a second or a Google years? The current best estimates say the lifetime of the vacuum is much longer than the current age of the universe. We are likely safe for billions of years. But probability is not a guarantee. You can win the lottery on the first ticket. The universe could decay tomorrow despite the odds. The expected value of our remaining time is high, but the variance is infinite. We are betting our lives on a game where the odds are good, but the stakes are infinite. The visual of the void is compelling. When you look at a dark patch of sky, you are seeing the absence of stars. But in vacuum decay, the void comes for you. It is an active void, a hungry void. It turns the concept of nothingness into a predator. We are used to filling the void with our imagination, but this void consumes imagination. It is the antimatter of thought. It is the physical manifestation of the end of the story. Stability is a relative term. The Earth is stable until an earthquake. The sun is stable until it runs out of hydrogen. The vacuum is stable until it isn't. We crave permanence, but the universe offers only temporary equilibrium. Everything is falling. Some things just fall slower than others. Vacuum decay is just the fastest fall. It is the ground rushing up to meet us. We have been falling since the Big Bang, mistaking the air rushing past us for stability. The Grand Unified Theory, GUT, seeks to unite all forces. If we find it, it will tell us the ultimate fate of the vacuum. It might reveal that the vacuum is stable, or it might reveal that it is already decaying. The search for the get is the search for the final answer. We are currently reading the first few chapters of the Book of Physics. The last chapter contains the spoiler. We are racing to read it before the book catches fire. Entropy always increases. Vacuum decay is a massive jump in entropy. It releases the potential energy of the vacuum into heat. It creates a chaotic, high-entropy bath of particles. It is the universe fulfilling the second law of thermodynamics in the most efficient way possible. The universe wants to decay because it wants higher entropy. We are standing in the way of the universe's desire to be messy. We are the orderly obstacles that need to be removed for the universe to reach its goal. The black hole information paradox suggests information is never lost, but vacuum decay destroys the structure that holds information. Does the information survive in the true vacuum? Or is it truly deleted? If it is deleted, it violates quantum mechanics, unitarity. This suggests that vacuum decay must preserve information somehow. Maybe the bubble wall encodes the data of everything it destroys. Maybe we become a hologram on the surface of the death bubble. We become a memory etched into the wall that killed us. Strangelets are the cousin of vacuum decay, a stable form of matter that converts everything it touches. If strange stars exist, the universe has already produced the contagion. It is just contained by gravity. Vacuum decay is the uncontained version. It is the contagion of space itself. We look for strange stars to prove that absolute stability is a trap. If matter can fall into a lower state, space can too. The existence of one implies the possibility of the other. The fine-tuning argument is often used for God. God tuned the universe for life. But if the universe is metastable, he tuned it to be a trap. Why? Maybe to keep us on our toes. Or maybe the designer is incompetent. Or maybe there is no designer. Just a random selection of parameters that happen to allow for a temporary, terrified observer. The metastable universe is the strongest argument against a benevolent designer. A benevolent architect doesn't build a nursery on a fault line. Cosmic censorship might save us from seeing the singularity, but it won't save us from the vacuum. The bubble wall is the censor. It censors our existence. It prevents us from seeing the true physics. We are allowed to live only as long as we remain ignorant of the true nature of the vacuum. The moment the vacuum reveals its true face, we cease to exist. It is a truth that kills. We are shielded by the lie of the false vacuum. Dark matter is the ghost in the room. It might be the key to stability. If dark matter is a heavy particle that couples to the Higgs, it could stabilize the potential. We are terrified of the known, Higgs/top quark, while ignoring the unknown, dark matter, that might save us. We are pessimists because the data we have looks bad. But the data we don't have might be good. We are judging the trial before all the evidence is in. Eternal inflation means the universe creates infinite volume. Even if bubbles eat huge chunks of it, the space between them expands faster. The universe outgrows the cancer. Life can always exist somewhere in the foam. We might die, but life continues. The cosmos is robust, even if we are fragile. This is a cold comfort, but it is a form of immortality. The song continues, even if our instrument is smashed. Quantum tunneling is probabilistic. It is random. This means the end of the world is a random event. There is no cause, no villain, no reason, it just happens. This randomness is the hardest thing to accept. We want a narrative. We want a climax. Vacuum decay offers only a sudden cut to black. It is an anticlimactic end to the epic of humanity. It denies us closure. It is the ultimate unfinished sentence. The universe is under no obligation to make sense to you, Neil deGrasse Tyson said it. Vacuum decay makes sense mathematically, but not emotionally. It insults our sense of narrative. We think we are important. The universe thinks we are a fluctuation. The conflict between our ego and the physics is the source of the horror. We are fighting for significance in a universe that treats us like noise. String theory proposes $10 carat, $500 different vacuums. We are in one. There are $10 carat, $500 other ways space could be. Most are dead. Some are alive. Some are decaying. We are exploring the landscape of string theory. We are hikers on a mountain range of potentials. We found a nice valley, our vacuum. But we are realizing it is a crater that is about to collapse. The landscape is treacherous. We should be careful where we step. The Big Rip is the other contender. If W less than -1, phantom energy, the universe rips apart. Vacuum decay is W changing. Both end in destruction. It is a choice between being torn apart or being melted. Physics offers us a menu of doomsdays. We are trying to figure out which item we ordered. The waiter is coming, and he is bringing the check. Technological singularity versus vacuum singularity. We race to build AI god minds. Maybe they can solve the vacuum problem. Maybe they can stabilize the field. Or maybe they will be the ones to trigger it. We are building our successors, hoping they are smarter than us. But even a superintelligence is bound by the laws of physics. If the vacuum is unstable, even a god cannot fix it, unless the AI finds a way to leave the universe. Escapism is impossible. There is no outside. The universe is all there is. If the universe decays, there is nowhere to run. This claustrophobia is real. We are trapped in the bubble. We can look at the walls, but we cannot leave. The only escape is into the true vacuum, which means death. We are prisoners of existence. Legacy is a biological drive. We want to leave a mark. Vacuum decay erases the mark. It deletes the stone the mark is carved on. It deletes the light that would illuminate the mark. It makes all effort temporary. This should be depressing, but it can be freeing. If nothing lasts, then the pressure is off. We can just live. We can enjoy the sandwich. We can look at the stars without needing to conquer them. The great filter might be us. We might be the ones who survive because we are too stupid to build the collider that kills us. Or we might be the ones who figure it out. We are at the crossroads. The next 100 years of physics will decide if we are the masters of the vacuum or its victims. The test has begun. Observer effect. Does the universe exist if we don't look at it? If vacuum decay kills all observers, does the universe cease to exist? In a way, yes. The lights go out in the cinema. The movie continues. Physics continues. But there is no audience. A universe without observers is indistinguishable from nothing. We give the universe meaning. When we die, the meaning dies. False vacuum is a warning label on the universe. Contents under pressure. We ignored the label for 13 billion years. Now we are reading it. It says, "Do not puncture. We are holding a needle." The drama of human history is us deciding whether to poke the balloon. We are curious children. We usually poke the balloon. Cosmic horror is not about monsters. It is about scale. It is about the indifference of the massive toward the tiny. Vacuum decay is the ultimate scale mismatch. The entire universe changes state, and we are just noise in the signal. We are not even a rounding error. We are less than that. We are zero. Hope is irrational. The math says doom. But we hope anyway. We hope for a mistake in the calculations. We hope for a savior particle. This irrationality is human. It is what keeps us going. We stare into the abyss and say, "Not today." And so far, we have been right. Every day is a victory against the vacuum. The end is a concept we invented. Nature has no ends, only transitions. Vacuum decay is a transition. It is the universe turning the page. We are the ink on the previous page. We don't get to be in the next chapter. But the book continues. The story of energy and space-time goes on. We were a good chapter. Gratitude. We should be grateful. We got 13.8 billion years. We got to see the stars. We got to understand the Higgs boson. We got to figure out the puzzle. That is enough. It has to be enough. Because it is all we are going to get. The universe owes us nothing, and it gave us everything for a little while. The edge. We are living on the edge of reality. Literally, the metastable edge. It is a thrilling place to be. It makes every sensation sharper. The coffee tastes better when you know the cup could dissolve. The sunlight is warmer when you know the sun could vanish. Vacuum decay makes life vivid. Science is the bravery to look. We looked. We saw the cliff. Now we have to stand on it. We cannot close our eyes again. We are the species that knows. We are the watchers of the vacuum. We hold the vigil. We keep watch over the fundamental constants. Legacy is not stone. Legacy is understanding. We understood the universe. We calculated its heartbeat. That is a legacy that transcends matter. Even if we are erased, the fact that we knew is etched into the timeline. We solved the riddle before the game ended. Acceptance. The final stage of grief. We accept the false vacuum. We accept the risk. We choose to live anyway. We choose to explore anyway. We build the ships. We build the colliders. We rage against the dying of the light, even if the light is destined to die. Beauty. There is a terrible beauty in the math. The equations are symmetrical, elegant, and lethal. The universe is beautiful because it is dangerous. A safe universe would be dull. We live in a masterpiece of danger. Silence. The universe is silent. Maybe it is holding its breath, waiting for the drop. We are the sound in the silence. We are the music of the false vacuum. We play our song until the instrument breaks. And it is a beautiful song. The future. It is unwritten. The probability is not 100%. We might be wrong. We might be safe. We might live forever. The uncertainty is the space where hope lives. We live in the gap between the data points. The present. Right now, the vacuum holds. Right now, you are here. Right now, the laws of physics are working. Take a breath. Feel the solidity of the world. It is a gift. Do not waste it. Reality. It is stranger than fiction. It is scarier than fiction. But it is ours. We own this fragile, metastable, beautiful reality. It is our home, and we will defend it with our minds until the very end. So look up at the night sky. It looks calm, it looks eternal. But now you know the truth. It is a mask. Behind the stars, the vacuum is waiting. Sleep tight.